Hello, everyone. A very warm welcome to all of you attending the Serverless Saturdays fifth edition. I hope you guys are all safe and during this difficult times. And really thank you for joining us today as a part of Serverless Saturdays.
So we have two amazing speakers lined in for today. We had an awesome session back then in May. So Srishit, would you like to take forward and tell to everybody about the speakers?
Yes. Okay. So, as a part, most of you guys already know what we do as a part of Serverless Saturdays. So, it is an initiative from the AWS user group Tirupati and the Serverless group from Bangalore. So, it is a monthly free webinar that we do where we get experts from across the globe. Share their knowledge and experiences about building serverless applications in the real world, and where beginners get a chance to listen from the experts directly and learn more about it. So uh, a couple of announcements before we get started with today's session. So, AWS reInvent has been announced, and the this time it's going to be a hybrid model where it's going to be in person as well as virtual. So, if you guys are planning to attend it, I think we'll post the reInvent registration link here in the chat section. You guys can go ahead and register yourself. Anyways, it's a virtual event, so you guys can certainly attend. And if you're planning to uh, uh, go and visit in person, which is actually happening this time, you can register for the tickets as well. So reInvent is happening this time in person. That's some great news given the current scenario and situations that we are in. Another announcement, again, with respect to the reInvent itself. So AWS, like every reInvent, has come up with the All Builders Welcome Grant, where AWS will take care of sort of a sponsorship for underrepresented technologists in the first 5 years. So if you are someone who is in the early stages of your career, just started, and less than 5 years, and if you feel like you are someone who can contribute to the community, who have been contributing but with not much of acknowledgement and stuff like that, you can certainly go here and apply for that grant. And if you get through, then you get an all expense trip to reInvent happening this year. So again, we'll paste the link here as well in the chat as well. So you guys can go ahead and apply it. And the best, you go and attend reInvent at no cost. So please do go ahead and apply for the same. And one more great news that we wanted to share with all of you is we are 500 member family right now, and so thank you everyone for being a part of our journey. We've just started, and we are already 500 members in a few months, and I think that's a great achievement. So thank you everyone for being a part of this amazing journey. We look forward to coming up with a lot more sessions and a lot more interesting stuff. And so, yeah, looking forward to a lot more sessions, experiences, sharing with you guys. So, thank you so much once again from all us at AWS User Group Tirupati. So today's session, we have two amazing sessions planned today. The first one is by Gareth Mc Cumskey, from Serverless Inc., who will be delivering a session on event-driven serverless microservices. And serverless framework, I don't have to introduce it to most of you guys, I believe. If you have been using serverless, then it's most obvious that you would have played around with serverless framework at least once. And we certainly have been using serverless framework for almost all of our projects for quite some time. And I must admit, if you have not used it, then you certainly are missing out on a lot of stuff. So please do try it out. And we have Gareth from Serverless Inc. itself, and that is really amazing to hear out the best practices and things from someone who's built who's a part of the team that is building the serverless framework. And the second session we have is from Azuga Telematics, Sindhura Ramesh. So she will be talking about more with less on serverless, where they have built a serverless enterprise application from scratch. And she'll be sharing her insights and knowledge about how to go about building an enterprise serverless application. I mean, we always want to listen real world stories from people who have been using it day to day in their production workloads, and we have one such story today lined up. So, Gareth, I'm just adding you to the stream. Hi, Gareth. How are you doing?
Good and yourself. Thanks for asking.
So, thank you so much, Gareth, for joining us today. And would you like to start by introducing about yourself?
Sure. Well, the introduction is also part of the talk, but I'll just hop ahead and do it here as well. My name's Gareth Mc Cumskey. You got it right the second time. Thanks. Most people get it wrong always, so I'm very impressed. I am a solutions architect at Serverless Inc. So my job is pretty much working with users of the serverless framework, trying to help them find how to solve the problems that they're trying to solve, and just generally assisting the developer community in using the serverless framework. So very, very happy to be here today.
Thank you so much, Gareth. So, over to you, Gareth. All the best.
Alrighty, I'm gonna get the screen share up and running. Oh goodness, me to get this. All right, so we're gonna see everybody's lovely faces for a second while I switch tabs. And can everybody see this? All right, is that all looking good?
Yes, it's all
Yes.
Okay. So, right ahead of time, I'm going to jump ahead and just make a couple of disclaimers. So if everybody's wondering why this speaker from Serverless isn't showing his webcam, I apologize, because recently my family and I all moved to Portugal from South Africa, and right now we're staying in an Airbnb while we wait for our rental home to be ready. And unfortunately, the house we live in has almost zero internet. So I'm sitting in my car at the moment, broadcasting to you guys from the local village that has about 20 houses in it. And yeah, it's not a very pretty picture, me in the car in the early mornings. It's about 6 a.m. So apologies ahead of time, I hope. And if things cut out, I will not be aware, because this is filling my screen at the moment. So I hope everybody can see everything clearly. And if the internet goes a bit flaky, I do apologize. That's mobile 4G internet in the countryside of Portugal. So yeah, thanks again for having me. The talk that I wanted to give today is a design pattern that I think is one of the most powerful design patterns you can use when building serverless applications. So I'm pretty excited to present this to more and more folks. And it's not uncommon to see this design pattern used, but it's always nice to introduce it to additional serverless developers, so everybody can see how powerful serverless can be in so many different ways. And like I said, I had an intro in the beginning as well. Gareth Mc Cumskey, solutions architect, yada, yada, yada. Been building stuff for the web for about almost 20 years now, I think it is. It's crazy. I feel like an old man. But anyway, this is me if you didn't get a chance to see my little profile picture. And yeah, let's get cracking. So, oh, and one last thing. I have noticed that there seems to be a rogue process on my laptop in my car that's eating battery. So I hope this doesn't die before I get to finish and answer some questions. But anyway, let's press on. So first of all, you might have looked at the title of my talk and wondered why this talk is such a buzzword heavy thing. I mean, we have event-driven, serverless, microservices. It couldn't get more buzzword heavy if you wanted to, unless you added in something like cryptocurrency. But thankfully, I'm not going to be talking about that today. It's only going to be the event-driven, serverless, microservices stuff. So to get past the buzzword bingo lingo that's happening here, just on the name itself, let's actually take a look in more detail at what I mean when I'm using these terms. And they're actually specifically used to describe a very powerful design pattern. So what is serverless? And I know we're all a group of serverless people, and you're wondering, why is he introducing serverless? It's more just to make sure that we're all kind of on the same page when we think about serverless and what we mean by it. Serverless has gotten lots of different definitions in the past, and people think of it in different ways. So let's just make sure we're all on the same page. So I normally like to think of serverless in the context of an actual application that I might be working on or building. And for me, serverless is the ability to replace infrastructure and code with managed services. And that for me is the very short, brief definition that I tend to like to use for serverless. So if we take an example, you're building a web application and you have the holy trinity of a web application. You need network to be able to manage HTTP requests. You need an app layer. You need some kind of code or something that executes on this request to perform your business logic. And you need a database to store the data related to your application. Those are the three basic things you need for any web application. And the idea is that you can replace each of these with managed services in the serverless world. So, for example, if I want to replace the network or HTTP requests, as well as even potentially the routing module in my code, I can use a service like API Gateway, a very powerful service that lets me do a lot of things and replace that entire network layer very seamlessly and easily without having to manage any servers. The same can be said for my application code layer. And generally speaking, in serverless, I always tend to find that I try to use as many of the managed services available to me in the cloud as possible. So I will usually look to use other services like S3, SNS, SQS, Kinesis, Dynamo, whatever might be out there to replace the application layer of my application. I want to write as little code as possible because code is the most likely thing to fail. So Lambda is there, and I can use Lambda to write my business logic. But if there's a managed service that can do it instead, I'd rather use that. Lambda is there as my last resort. And there's my compute layer replaced with a managed service. And then, of course, we've got our database layer. And these days, in the good old days, you would basically use a relational database, and that was it. You made use of that. That was how you stored your data. That was how you would always store your data. And there was no other. There wasn't a alternative to that. These days, with the advent of the cloud, things are a lot more different. You have a lot of different database options available to you, and you do have something like relational databases available to you, but you'll find in the serverless world that alternatives like DynamoDB are very, very commonly used. And you'll find that you can now use these different database engines for the purpose that they were meant for. So you don't have to use a relational database as the hammer to every nail. You can now pick the right database tool for the job. And then everything else that you would normally have run with a traditional web application, like the OS, the CPU, application updates, load balancing, all that other stuff, is just not your problem anymore, which is what makes serverless so awesome. And you usually find serverless applications are built using a pattern called Jamstack, where you end up having a front end built with some kind of front end tool that generates HTML, CSS, and JavaScript that ends up getting hosted on something like S3 or Netlify. And you have a back end that the front end makes API calls to do all the dynamic stuff that you need. So now that we're all kind of on the same page when it comes to what microservices, serverless is, let's take a look at what microservices are just again, so we all understand what I'm talking about. And essentially, microservices, the idea with a microservice is that each service that you generate as a microservice is a mini application unto itself. If you were brought up in the days where service-oriented architectures were a thing, this might sound familiar, but microservices are a much smaller subset of what a service-oriented architecture service might look like. Service-oriented architectures used to be much bigger, fatter services that you would run for your application, whereas microservices tend to be much smaller in their scope and domain. They tend to focus on doing one thing and doing that one thing really, really well. And if you're trying to figure out how to scope your microservices to find the right size and what they should contain, I would suggest taking a look at something called domain-driven design. It's a really great way to help you decide how to break up your microservices and how to scope them. And the idea with microservices is that you try to keep these services as independent as possible so that you could potentially take a single microservice, spin it up in another environment, and you're home and away. You've got a brand new service up and running that you've been able to reuse as seamlessly as possible. One way to accomplish this as well is to not share data stores. And this typically is where traditional microservices, as we'll take a look at, tends to struggle. But in the serverless world, this becomes a lot easier to do. And traditionally, microservices as well when you think about them in the Kubernetes world, has a massive infrastructure burden, because running a single application is doable and not terribly complex. But when you start breaking out into a collection of microservices, each one of these now needs to be managed and maintained separately. And if you're doing that using Kubernetes and containers, it becomes very complex very, very quickly. Okay, so now for the last one of these buzzwords, event-driven. So what do we mean by event-driven when we're talking about this in this design pattern? And just to clear it up, I'm not necessarily talking about Lambda events. If you've used the serverless framework or other serverless frameworks that are out there, you might be familiar with the concept of attaching AWS or cloud events to your Lambda functions or your functions as a service code. That's not what I'm talking about here. When I'm talking about events, I'm not talking about those specific events that trigger Lambda functions. What I'm referring to is domain events that happen in the application that you're building. And as an example, what I mean by this is if, for example, I receive an HTTP request on my API gateway endpoint, that event, that AWS event will trigger my Lambda function, but the actual application event that happens is a create customer event that comes from that. And so on and so on. You have different events in your application that you're building. All right, so we've talked about these three terms individually, but what about the concept of event-driven microservices? What does it look like without serverless in the loop? And this is actually a thing. So these do exist. This is typically how you'd find microservices developed, generally speaking, out in the traditional non-serverless sense. But the overhead for these, as briefly mentioned before, can be pretty huge because you have this huge collection of microservices that you need to manage via Kubernetes and containers and Docker and so on. It becomes pretty hairy pretty quickly. You have to worry about things like your compute platform. So when you're managing these systems, you have to worry about whether you're going to run what Linux OS you're going to run on, if it's Linux at all, what the application frameworks are going to be like. You need to manage all the different software that's used on your compute platform. It starts becoming heavy to manage. And on top of that, now you need to manage your data platform. How do you store your data? And Kubernetes and container systems traditionally, although they have solutions now, have had issues dealing with data platforms because Kubernetes and containers are ephemeral and these containers just destroy themselves over time. Whereas your databases, you don't want these things being destroyed. You want your data to persist. So this becomes tricky to manage. And then you have to manage whether you want relational, MongoDB, Cassandra, or any other potential data platform. And then add on top of that, in the context of what I'm talking about today, as you'll see, we also care about our messaging platform. So are you going to use RabbitMQ or Kafka? If you're running your own suite of microservices, how do you configure these? Do you have the expertise to manage them and know how to configure them correctly for optimal performance and so on? It becomes a lot of work. Not to mention the ability to add sidecar processes on, do you want to have authentication, authorization? What about IAM? All these other extra bits and pieces that get attached to your services that you need. You have to do this yourself as well. And yeah, there's so much more to this. I'm scratching the surface about what potential landmines can sit waiting for you when you're managing your own microservices cluster. But in our world, obviously, I'm at Serverless Saturdays. We are adding serverless into the mix, and this helps solve a lot of problems for us because ultimately, when it comes to building our own microservices, all we really care about, sort of on an infrastructure, and I put that in quotes level, is service volume limits. I don't particularly care about all the underlying implementations of anything. I purely just care about my volume limits because if I make too many requests to API Gateway, I know what those limits are. I can go see how much of those limits I'm consuming, and I can plan ahead for if I might hit those. But not only that, because these services have these limits built ahead of time, they also tend to error out pretty cleanly. So if I overutilize my DynamoDB table, it's going to return back with a very clean response to the code that's trying to do something to DynamoDB, and I can code accordingly for that. Whereas traditionally, if I have something running on a Kubernetes cluster and it overutilizes the CPU, I just have errors thrown because the CPU is no longer available to execute a task in the time required. And it's very difficult to code for those eventualities. So nice, clean error message just makes managing limits nice and easy for me. And of course, now we know this already, I've got none of that management and configuration overhead. I don't have to worry about CPU, memory, OS updates, application updates, and the rest. I can just worry about my application. And a lot of this is also handled for us by the serverless framework. Using a framework for my serverless application means that I don't even necessarily need to think all that hard about all the infrastructure that I may be using in AWS. Even if there are managed services that essentially manage themselves, again in quotes, proper frameworks like the serverless framework mean that I can code according to what my application needs, and it'll manage the infrastructure for me. It'll deploy into my AWS account what I need in order to accomplish the task that I need for the application I'm building. And of course, there are other frameworks. I'm going to have to mention them. I'm just the most familiar with serverless framework for very obvious reasons. But there are other frameworks. If you want to try something else, I always recommend, and I've met folks who do manual serverless applications themselves, and I always highly recommend folks to use a framework of some kind, even if it's not the serverless framework. Just do yourself a favor, try and use a framework to rather help you do these things. If you want to try doing it manually yourself for the first time, just to see what that's like, go for it, but you'll very quickly appreciate using a framework that helps abstract this away for you. It's pretty nice. So what problem are we actually solving? I mean, there's no point looking at a design pattern or solution to something if we don't have a problem to solve. So one of the, and I forgive me, that is a bit light, I just noticed. But one of the problems we're trying to solve is that traditional web applications that we've built in the past, I'm talking about the monolithic web applications that you'd build on backends like Symfony, Laravel, Flask, and so on. They tend to be built in a very synchronous way. And what I mean by that is an HTTP request might come in for a client that needs to be fulfilled. That then will go hit a front controller, which forwards that to an action in my MVC style architecture. That action will now process the request and will write to the database, maybe send an email, go ahead and pop a message into my message queue system, maybe do additional transforms on some things and write some more data somewhere else. And then eventually 5, 6, 10 seconds later, respond to that client requesting data. That's not necessarily the greatest way to do things. So let's try and solve that problem. The problem with any kind of system like that is that traditionally, if you're running on virtual machine clusters or a Kubernetes system, these kinds of architectures struggle under load. Even if you have dynamic virtual machine clusters that are going to spin up for load balancing purposes. And not only do traditional web applications built on VM struggle from these, but serverless applications can inherit these kinds of synchronous problems as well, where you're holding up your client from receiving a response. This ends up leading to that high latency for clients that I was talking about, which in the world of e-commerce and fast response and short attention spans, you don't want users of your application waiting around for seconds at a time. Anything more than a second these days ends up being far too long for somebody waiting around for a response. And these systems also will produce very poor performance under load. So your system suddenly gets hit with a lot of requests, and everything is now going to perform worse than it would have under base load. In the serverless world, this doesn't just mean bad performance, but can also lead to higher cost overall, because now that you're doing everything synchronously, your Lambda functions are running potentially longer than they need to, and it's going to end up just costing you money on your AWS account in the first place. So what are the goals of our architecture? What is it that we are actually trying to accomplish, and how are we going to get there? So one of the ideas is one of the goals we have is that we want to make sure we build an application that is low latency for our clients. First of all, that sub-second return is really what we want to get. We also want to make sure that we have resiliency of our backend. So if one thing in our backend falls over, we don't want everything else to fall over, which is traditionally an issue with monolithic applications in the past. We also want resiliency of our data stores. We don't want to write data to somewhere and have that be unavailable and the entire application falls over. We would like a way to make our application more resilient to failures of our data stores. And that happens even to DynamoDB. It might be a managed service and it runs really awesomely, but you can have DynamoDB tables have issues. And we also want event resiliency. I mentioned the idea of these events that we want to have in our system. I also want to make sure that they are resilient, that they can continue to be fired and happen even when other parts of the system may be underperforming. And our client interactions, and this often happens a lot in the monolithic application sense, where your client interactions create blocking processes in your backend. Something locks a database table, something eats up too much CPU and causes all the other threads to back up. We want to make sure that this kind of thing doesn't happen. All right, so how do How do we actually solve for that? What are the steps we can use to help us solve this problem? And don't worry, it's going to turn into more than just a bunch of slides with text on it in a minute. So first of all, one of the things we want to look at is having a collection of modular microservices that are independent from each other. And this provides us pretty much all the resiliency that we were talking about before that we want to make sure our application has. We also want to have independent data stores per microservice to provide our data resiliency. So what we don't want is all our microservices sharing a single data store. And if that single data store has an issue, all of the services now suddenly don't have access to the data they need. And we also want to try and prefer asynchronous communications as much as possible so that we don't block requests, and it also will improve our client latency. So 2 birds with 1 stone there. Asynchronous communications in the serverless world is the killer feature that you need to use as much as you possibly can, and we'll take a look at that as well in a minute. Okay, I've talked a lot, and I'm kind of rushing this a bit because of the aforementioned battery issues that I was talking about. So let's look at something a bit more concrete that we can see kind of in action. So let's take a look at a bit of an architectural diagram. And this is the last time I'm going to mention the front end. But for most web applications, you can have a front end of some type. And in the serverless world, you tend to have a Jamstack style application with a front end build with something like React, Vue, or Angular. Doesn't matter. You can use Svelte. You can use whatever front end framework of choice you like. What you'll end up having is all your static files sitting in an S3 bucket or Netlify or so on that can serve these static assets, and they will make requests to a backend that you have. And we're going to spend all of our time pretty much looking at the backend part of this infrastructure diagram. And as I mentioned, HTTP is the communication layer between your front end and your backend. And to look at our backend now in a little bit more detail, let's take a look at a backend with 3 services as an example. We have a customer service, a product service, and an order service. And each of these 3 services now are domains that handle specific entities individually. We have our customer service, which manages customer data for us, our product service that manages our product data for us, and our order service really is a relational entity that manages the combination of customer and product together as relational data. And this is a very small amount of data, but this is the typical type of data you might see for each of these services. Your customer might have some email, first name, last name, address. Your product's going to have some product information like the name, description, size, and price per unit. And your order, as you can see, is a combination of the 2. You're going to have the email of the customer, the address to deliver to, and the array of products in the order for this customer. And this is our basic application that we're going to look at as an example of this design pattern. So let's just zoom right into this backend and look at it in a bit more detail. And we're going to take the customer service on its own. This is the simplest of the 3 services. So I thought let's just take this in isolation and see what the internals of this service look like for this design pattern. And right away, we start off with the service needs to be able to receive HTTP traffic from the front end. So your front end layer is going to speak directly to your backend services via HTTP. And this is going to end up triggering a compute layer inside your service that's going to execute on this HTTP request. It's going to take the data from that post request, process it in some way, and then potentially store it in a database of some kind. So you're going to connect your compute layer to your database to store your data. And at this point, that interaction is maybe 100 milliseconds, maybe 200 milliseconds. But at this point, you can then respond to the client that made the request to create the customer with a 201. You've persisted the data from that request in a database of some type. So you're confident now that you can respond with a 201 and you can continue doing whatever processing you need to because we have some more to do. But our client is now not held up waiting for us to finish the additional processing before we respond with a success message. And what ends up happening now is that our database has the ability to trigger another compute instance. And this is now going to process based on the change of data in our database. In this case, we added a customer, but we could have edited one or deleted one, and we still want to process that data storage event. And what this compute instance is normally going to do is going to look at that data and say, oh, this created a customer. Let's go and emit that event to the rest of my application using a pub sub service or an event bus of some kind. And let's push out that customer created event to the rest of my application. And this is the general structure of what you'll see in a service. But let's break it down into what the actual parts in, for example, AWS looks like, just to make it a little bit more concrete. So here you can see, for example, I've got API Gateway, and I'm going to use my mouse just to show here. We have API gateway as our layer that handles the HTTP layer, and they can then route this request directly to a Lambda function. So our Lambda function is processing this request. Lambda will then write this to DynamoDB, for example. And in this use case, I like DynamoDB. DynamoDB is a fantastic tool that if you haven't looked at using at all, you really should take the time to look at it and consider using it. It's a fantastic database layer for the front end of your application that receives the most volume of requests in your application. DynamoDB is really performant under high load. It's very consistent in its performance, and it's pretty quick at writing and reading data from the data store itself. So it's a really great frontline tool where you receive the most traffic, and you can then relegate your relational databases to your reporting engines in the background. As you'll see, we can do that with this kind of architecture. So I could spend hours talking about DynamoDB by itself. I'm not, but I'm going to recommend looking for the DynamoDB book by Alex Debris if you really want a great source of information on DynamoDB. He used to work at Serverless and then wrote a book on DynamoDB. It's probably the best book out there on DynamoDB, in my opinion. All right, so enough of the selling of a friend's book. DynamoDB has a great capability of having a feature called streams, and you can use DynamoDB streams to then trigger a Lambda function, as you can see here. So when I write data to DynamoDB, it can then trigger another Lambda function with that database, that data change. And this Lambda function will now see that the data added to the data that came into DynamoDB was an addition. We created a customer. So it knows that it needs to now propagate this customer-created event out to the rest of the application. And this can be done using SNS, which is what I've used traditionally in the past. But EventBridge is is the new hotness these days, and is a really great tool for this kind of architecture as well. All right, so let's take a look at a bit more detail of a more complex service, the order service, which is the relational entity. And to create a new order, let's just consider what this would look like in a traditional application. We would traditionally have built this as a relational entity. So we would have, instead of storing customer and product information as a part of an order, we would normally have stored the customer ID and the order ID and the product IDs together in a one-to-many relationship of some kind, so that we're not speaking about an order. All I'm doing is resolving a customer ID to get the customer information and resolving product IDs to get the product information, usually through a join, excuse the motorbike, normally through a join on in my relational database. And that's traditionally how you would do it. However, in our system, this is a little difficult because we've decided not to share data stores. So typically, the order service does not have direct access to the data stored in the customer service. That's by choice. We've designed it that way. But we need to solve this problem. We need a way to reference customer and product information when we're talking about an order, because that's all an order is. So one way you might think that's easier to solve that, and you can maintain this sort of customer product ID relationship, is just use the API, right? If I'm just storing the customer ID, why can't I just make an HTTP request to the customer service to get the customer information when I need to? And the same for products. That sounds like an easy solution. However, it's not. I've done this. It doesn't work incredibly well. And let's take a look at why. If I have my three services again, and I have my order service, and this is the pattern we were just talking about. Why can't I just use HTTP to make requests from my order service to my customer and product service to resolve those customer and product IDs? The problem is that if I suddenly have my customer service becomes unresponsive, my order service no longer works either. So I've now made my order service more vulnerable to failure if my customer service, for some reason, stops responding. I now have a hard dependency between my order service and my customer service. And this breaks one of the goals that we have, that we wanted our services to be as independent as possible. Not only that, but I can actually induce failure of my customer service if my order service suddenly gets really busy. And what if I have 20 other services that all want to make requests for customer ID information from my customer service? I'm more likely to bring my other services down and then affect my entire system and bring my entire system down. This has happened to me actually in the past. So I know from personal horrific experience that this happens, and you tend to want to avoid this if you can. And luckily, that's exactly what we're designing for. We're designing to avoid this kind of eventuality. So let's take a look at another way to solve this problem. And if we want to avoid making requests from the order service to the customer service, the way to do that is to not have to make those requests. And that sounds obvious, but what I mean by that is you can actually do something like keep a projection of customer data within the order service itself. So instead of requiring a connection, direct connection to your customer service to extract customer information, you're actually maintaining a list of customers within the order service itself. And this is done because we were propagating these events. The customer service, every time a customer is created, updated, or deleted, we're pushing this out as an event for all the rest of my system to see. And the order service is listening for these events. And if a customer is created, it adds that customer into its customer projection table. If a customer is deleted, it removes that customer. If a customer is edited, it edits that customer. And the advantage here as well is this customer projection doesn't have to have all the customer information that exists within the customer service, only the data that the order service needs in order to resolve an order. It's pretty handy. The other advantages we have here is because the customer service is the source of truth for customer data, if for whatever reason our customer projection here gets corrupted in any way, that's not a problem. We can actually delete this table at any time. It doesn't matter because the customer data resides here. We can then rebuild this table based off of the data in the customer service itself. So we get resiliency here where customer data, it kind of doesn't matter. We don't need to worry about having ultimate redundancy on the customer projection because we already have a permanent backup in our customer service, which we then maintain our proper backups on and so on. And here we have our orders a table that can now refer to customer IDs in my customer projection if I choose to. Much more convenient. There's no HTTP requests. There's no redundancy. There's no talking to other services. It makes things a lot easier to manage. And typically what you'll find is this happens across the board. So we have our three services again, a customer service, a product service, and an order service. And the order service will have an orders table to manage the combination of customer and product, a customer table to manage our projection of customer data, and a product table to manage a projection of product data. And each of these is going to have its own set of events that it'll fire out into the application as a whole to help the order system and the order service and other services that need customer or product data maintain their own local projections of that data itself. And what advantages does this give us? So, I mean, I think it might be pretty obvious, but what happens is we get all the benefits of microservices out of this architecture. We get full service autonomy. I can take the order service and deploy it on its own. It may not build customer projections because it's not receiving any customer events without a customer service. But the order service works. It actually does function. It might not return any orders because it has no customer data locally. But I could, for example, inject that customer data manually if I chose to, and then now I can start reconstructing order information. But it doesn't have a hard dependency on requiring a customer service to exist at the same time. We also have service resiliency. If I now have other services go down, my entire system doesn't go down. If my customer service, my product service, and every other service in my system goes down, I can still resolve orders. I still have some parts of my application up and running, even though the rest of it's gone down. Nice resiliency there. And all the downsides that we mentioned that you get from microservices have effectively been removed by the addition of something like serverless application. We have no Kubernetes cluster to manage, so all of that complexity is gone. There's no load balancing that we need to worry about constantly. We don't need to worry if we have enough pods, enough CPU, enough VMs, and so on. And we have full observability that's built right into the framework. And right now in the serverless world, the serverless framework itself has a monitoring tool that's built into the framework itself that you can use to help keep an eye on things while you're building your applications and in production. And there are many other tools out there like that as well. So if you want to maintain some observability and monitoring on your a collection of microservices, this is available to you to use. It makes life a lot easier. We also have an improvement on the security aspect because our requests now go to each service directly from the client. There's no intermediate layer that may be intercepted that can affect our security. Things go straight to the services that need to act on those client requests. Each service can, because each service is handling its own HTTP requests individually, each service can then validate client requests since user data is probably propagated across all the services. So my product service can immediately look at the user data being sent to it and determine whether or not that person is allowed access to product data, and if so, what product data, individually. The rest of the services don't need to know or care about those restrictions on that service. This also eliminates the leaking of data because you can imagine in traditional systems, if somebody was able to compromise your API and get access, they would have access to your entire relational database usually. In this situation, because the data stores are distinct and segregated out in between each microservice, the only data they'll have access to is the data managed by that service and any projections potentially, and that's it. It doesn't automatically mean that a hacker now suddenly has access to all the data in your entire system. The other advantage is that exposing a single service also doesn't expose your entire backend. Just because one service was compromised, it doesn't mean that they can suddenly do everything on your backend, because it's all sitting as a single monolithic application. The biggest advantage of all that we get from all of this is that as a developer, my development time is now focused on outcomes and not infrastructure. By combining serverless and this microservices architecture, I can focus on building solutions for my customers and for the business that I'm working on. So this is a situation that I think a lot of us have had or will have in the future. I am working an application, and we need, on the front end, we need to produce something for our customers in the business. There needs an API that needs to be developed. And in a traditional sense, I'd normally have to go to the DevOps team or try and do it myself and find a way to spin up Kubernetes clusters and VMs and pods and configurations and install applications and make sure that things are updated. And that can take weeks. And the last thing I want to do is tell the business that they want a brand new feature that sounds relatively simple to do, but it's going to take weeks to implement because I need to spin up new infrastructure to manage this. Building things in the serverless way just makes this kind of situation less likely to happen. And this means that you ultimately have agility, because combining the microservices environment with serverless means that you have massive agility. You can spin up new services and create new things without having to worry about the interaction with other things in your application. You can create a brand new service that does all sorts of interesting things, just slot it in there. And because you're using asynchronous communications without hard dependencies, there's no need to worry about how this impacts the rest of your application. And this entire system, believe it or not, while it does sound like it uses a lot of services, it actually ends up reducing the cost because you only pay for actual usage. There is very little Lambda execution that's happening here. All the Lambda functions tend to be really quickly executing. API Gateway is limited in its scope. If you were using that pattern where you had an order service using API Gateway to speak to the customer and product service, API Gateway is the most expensive part usually of our applications. And this pattern means that you're not doing that. You're not using the most expensive parts to communicate between services, which reduces your costs. So it's a really great pattern to help reduce the cost of your serverless application. And your costs are even further reduced because you no longer need, if you're building things using serverless, you don't need the specialists in your organization that know how to manage virtual machines, Kubernetes, DevOps, all of this kind of stuff. You can just learn to use the serverless framework, understand your service limits, and just build your application. There's no need for these specialists that cost a lot of money to hire and run in your organization. All right, I think I may have run really quickly through some things, but I wanted to flesh this out a little bit with a use case. So I cannot see my screen. So anybody, if I'm running a little bit long, please feel free to let me know and pause me. Can I just do a quick check to see if I'm still online with everybody? I'm assuming I am.
Yes,
oh, awesome.
Yes.
Okay, great. It's difficult to see because all I see is an orange screen right now. All right, so I'm going to go through a quick use case, and if I'm running out of time, please feel free to button because I cannot see the time at the moment. So let's just switch over to a quick little use case study to help make things a little bit more concrete while I can. So this is an actual application. This is something I built a few years ago for a friend of mine. It's a microservices serverless application using the design pattern we talked about to varying degrees. So there's parts of this that I would do differently now, and you'll see that it's kind of done incorrectly, in quotes, according to the design pattern I've talked about. But I'm sure you can see, and apologies if it's a bit small. I try to use the presentation mode here, which generally makes things a little bit bigger. But anyway, we have a collection of microservices here, and immediately you can see these are scoped according to very specific things that each of them does. An authentication service, this really handles user accounts and logging in and authenticating and validating users' access to a system. A subscription service, I'm going to hop to that because the subscription service handles whether a person has signed up and paid for their subscription. So this application requires a paid subscription to the service. And really what this does to make sense of these additional services here is that it's a restaurant. It's a service that lets you go to restaurants and receive discounts. So you sign up and you pay a monthly fee, and you book ahead of time for a restaurant that you want to take your loved one to. You go to the restaurant, you have a great time, and afterwards you claim a refund up to a certain amount from visiting that restaurant. It's a great little service in South Africa back when I was living there, that you could use if you eat out every now and then and just save a bit of money on eating out. That's why it's called going out. So we have a booking service. So if you want to book a place at a restaurant, the booking service handles making those bookings for the specific restaurant. The claim service is what is used when you're finished going to the restaurant and you want to claim your refund. The claim service handles those refund requests. The checkout service handles the payment of your subscription. So the checkout service speaks to the third-party service provider. The messaging service sends emails and SMSs. The report service is used internally by staff to generate reports of all the data in the entire system. And the restaurant service manages the list of restaurants that are available to subscribers of the service to make bookings at, to go eat out at. So you can see already this kind of describes a lot of the functionality available to you as a developer. But let's take a little bit more detail in some of these features. And I'm going to take a look at the authentication service here. And we're going to take a look at a serverless.yaml file. And right away, I'm going to just hop to a section here that you'll see I've got various HTTP requests happening in the system. So for example, I want to have an update forgot password endpoint. So people forgot their passwords. I want to initiate the forgot password process. I need to create users. So here's a create user event. I need to authenticate users that are logging in. So you can see here are my HTTP events coming into my system. But you can also see I have these other services sitting here with SNS. And this SNS here is looking to add new user scope. So it'll receive the create user event and then add some user data on top of that user. We can also see here that we have if we have a request to send the new user an email, if an email is sent to a user, this service will now receive that as a message from the SNS topic and then process on top of that. Nice and simple to use. And one of the other services that this makes sense for, so if I'm creating a user here, creating a user, it means that I need to find some way to propagate this user across my system, especially for my subscription service here, because my subscription service needs to be able to maintain subscription state on these users. So you can see here, if I go look at my subscription service, I can immediately go to my list of functions, just trying to find that here. And I have the create user event response. And this uses that create user SNS from my authentication service to run the code in my create user event response. And this handles receiving that SNS request and adding that that customer to the subscription service itself to manage the state of the customer internally. This subscription service then also will, this code actually inserts data into DynamoDB. And you can see here, I've got my second Lambda function that I talked about, receiving the DynamoDB stream from the DynamoDB table. And this Lambda function will now take the data written to DynamoDB and push that out into SNS. In this case, I could have used EventBridge, but this was 3-4 years ago now. EventBridge didn't exist back then, so I had to use SNS. And we can immediately see if I go to my subscription event code here, this is coming in, and this ends up writing to SNS eventually at some point. Here we can see it's publishing to SNS and pushing out the subscriber created event to the system as a whole so that it can then manage its data on the subscriber side. And in this way, the system sends data between the different services very, very cleanly. And the advantage of using managed services like SNS or EventBridge is that you don't have to worry about the failure of these systems because they're built very redundantly by AWS themselves. And in fact, I've had instances where SNS goes down in quotes, but the thing is it doesn't actually go down. It really just stops sending events for a little while. And eventually when it comes back up, it just starts sending the events that it had to send in the first place. So you never really miss out on anything. The other advantage, of course, is that even if something happens to the event system and tables go out of sync, you have a source of truth. If my customer table, for example, goes out of sync, my customer service has all the data for that, and I can just sync them back up if I need to. All right, I think at this point, I'm going to try and drop while I have the capacity to questions. And I'm going to just swipe back to here and just ask if anybody wants questions. Thanks so much again, obviously, for letting me talk about this. And I just want to mention, if anybody does in future or is nervous now to speak up or anything like that and wants to ask any questions, you can do so on Twitter. I have my DMs open there. It's Gareth MCC. I think my details are on the event here. Or even just email me at gareth@serverless.com. And I'm more than happy to chat to folks about any serverless questions. So yeah, any questions for the event? And should I drop my screen share? There we go. And I'll turn my camera on briefly for everybody who wants to see me sitting in a car, like I said.
I get it. So thank you so much for that amazing session, and thank you for doing it out of a car for us. And
you
that's
do what you got to do.
We have a couple of questions in the chat section. Guys,
Awesome.
if you have any questions for Gareth, this is the right time to shoot your questions.
I'm also taking a look through the comments. So can I quickly grab that one by Naveen?
Yes, please.
So Naveen asked, for anybody who hasn't spotted it, for improved resilience in serverless applications, can we use chaos engineering? There we go. It's popped onto the screen. Awesome. So the short answer is yes. The interesting thing is, though, you won't necessarily find it as useful in the serverless world as you would in the traditional virtual machine Kubernetes world, mostly because if you're setting up your infrastructure in that way for the first time, you do need some way of testing that you've configured things, set up load balancing, all that kind of stuff. The advantage of something like AWS is that a lot of this, what can I call it? A lot of the work done to prove that the services are resilient and up and running is done by the millions of other people using those services at the same time. So there isn't quite it's not as necessary. But if you want to test your own implementation and your own setup, chaos engineering, there are chaos engineering tools. I haven't used any of them myself. There are chaos engineering tools out there that you can use, and things like some of the tools from Netflix, because they run on AWS, although did they recently switch to Google? I forget. Anyway, they created a bunch of tools you can use in AWS that can do things like just break a service, destroy API gateway endpoints, all sorts of crazy things that you would never want to do yourself. But yeah, you can definitely use chaos engineering to help improve the resiliency of your serverless application.
Awesome. Let me just pull up another question. Oh, sorry, not this one. This was a comment. Here's the question.
Okay, so what is the opinion on using ALB in place of API Gateway? I found that there are hard limits on API Gateway and not on the ALB. All right, so this really depends on your use case. So the single biggest advantage that API Gateway gives you is that it takes away a lot of the work you need to do in code. So API Gateway, it's kind of a catch-22. API Gateway takes away things like routing. You don't need to worry about managing routing for yourself. Your endpoint points at a Lambda function directly. So there's nothing, you don't need to worry about that side of things. You can do things like, what is the word I'm looking for? Actually analyze data coming in. So if you have post requests that you want to manage the structure of the data, API Gateway can resolve those for you before it even hits a Lambda function. So you're not holding up a client that has to error out. The error goes out almost instantly because API Gateway has resolved it for you. There's a bunch of these features, API keys, domain management, a ton of stuff that you can do that API Gateway just takes away, that you don't need to worry about, that you would need to implement yourself if you use ALB. The biggest advantage ALB has is that it's much cheaper than API Gateway. But that cost is then consumed in the time that you have to spend implementing these features that you may want to use yourself. So if you don't need all the advanced features of API Gateway, go ALB. It's fantastic. It's high volume. It's much cheaper. It's a great way to go. If you do use API Gateway, I say use the features to their fullest, because API Gateway is one of the more expensive services in AWS. And the more the features of API Gateway you can use, the more value you're getting for every request. It just makes sense that way. So it really depends. If you want to make your life easier and don't mind spending a bit more, use API Gateway. If you want absolute power and throughput, but you're going to do more work, then ALB is where you go for that.
Thank you, Gareth. I think we have one more question from Smile herself.
All right, so I'm reading this in myself in my head, and I should just read it out. From a dev point of view, serverless has many advantages, one of which is that you practically don't have to worry about the infra anymore. In your opinion, how does serverless change everyday life of dev? Ooh, it changed my life completely. Okay, so I went from, and one example, a very simple example, is I went from having to spend 2 weeks, was it? Trying to find a way to make a collection of virtual machines more redundant by having to set up Amazon machine images that can then be spun up as needed to generate brand new EC2 instances in the back end if loads suddenly started climbing. And I don't know if anybody's had this similar situation or heard this kind of story before, but it can be a bit nightmarish when your application isn't built for it from, oh no, it was hell. And I ended up spending a lot of time doing this. I was the lead on a team, and the business kept saying, we need stuff for our customers. We need them to spend money and make the company money. And I was saying, whoa, I can't do anything. I'm still working on infrastructure. You got to wait. Serverless freed all of that up. We had a team of 3 developers, and we were able to push enormous amounts of features and functionality that I don't think anybody would believe, just because we were building things on serverless at the time. Our focus wasn't on infrastructure. Our focus was purely on driving feature deployments to customers. And here's one of the other biggest advantages. I talked about a design pattern here that you could use to optimize your serverless patterns. You can kind of do almost anything you like, and it's still going to run pretty well in using serverless. That's the one big advantage you've got. Lambda is so self-contained that even if you write the worst possible code in the world that creates infinite loops upon infinite loops, it's not eating your CPU. You're not affecting every other thread and every other request coming in from all your users, because Lambdas are self-contained. It's pretty awesome that way. So even if you write the worst possible code in the world, it's still going to run okay. At worst, you're going to get a bill, but at least the business is happy. They're still getting the features out, and then you can optimize later if there's problems. So focus on features first and optimization later if you need to. And just to add on top of that, cold starts is one of those things I see people talk about a lot. And it's usually the smallest possible problem you can have in your serverless application. Cold starts usually ends up being an almost nothing problem in production, but developers spend a lot of time and effort ahead of time worrying about it when they end up not needing to. And I found this out myself. We were worried about cold starts. We decided, screw it, let's just push this to production. And we had almost no issues with cold starts. So push your code to production generally, get it working. If it's working, use it. Then optimize if you need to. Worry about that later. So yeah, sorry, ranting.
Absolutely true. And adding to your point, we built one application where we were able to ship some crazy amount of features, just mostly because it was serverless and just focusing on what is the customer's needs and building out features rather than focusing on the infrastructure and stuff like that. And like you mentioned about the cold start, I think just worry when it actually is a problem instead of just talking about it from the very beginning.
Yeah, and one thing to mention, if you're in development right now and you're building stuff with serverless and you're seeing this cold start stuff happening all the time, that's because every time you push a change to your application using deploy, it resets your lambdas, and you're going to get a cold start when you test. So you're going to see way more cold starts than anybody in production is ever going to see. So don't let that cloud your judgment. Things seem slow to you because you're forcing a cold start every single time you test. So don't worry about it.
Awesome. We have one more question.
The design you've shown there could be read-write lag between the data stores. The moment you write in customer data store and try to access from auto data store, there could be delay in real time. And that is very true. That's usually not an issue. How can I put it? Well, the delay between them is literally milliseconds, unless there's issues happening in AWS in general, which happens from time to time, but it's actually not very common. I think I've had twice in 4 years that the read-write lag between services was so extreme that it was causing massive problems. What you end up having is front ends. How front ends are often built is that you'll do things like, I'm on my profile page as a user, and I'm editing my email address, and I hit submit. And usually the application will then send that request to save the data and then read it again from the database and then present it on the screen. And that's where you see the read-write lag. If the write that you've done hasn't written to the database when you try to read from the database, And that's often when it becomes very apparent that there's a read-write lag. And that is usually solved by not reading from the database you've just written to. You know what you wrote. You don't need to make a request to your database. So you make that post request to edit the customer data. You don't need to make another GET request to receive the data back. You just sent it. It's basically optimistic front end. You send the data, you get a 201, and you assume that was stored correctly, and you show that on the profile page as if you read it from the database. You don't need to. Tools like Trello do this. I don't know if you've noticed, you edit a Trello card, everything looks fine on the front end. If your network was acting up, a few seconds later, you'll get a message saying, this wasn't saved yet because your network was acting up. But until then, the front end kind of just assumes that things were working and acts as if it is. And that's just optimistic front ends that make that kind of lag less obvious. But yes, there is a slight delay, and you do need to be aware of that.
Awesome. I think we are right on time. Gareth, thank you so much for being a part of Serverless Saturdays, and we really appreciate your efforts of moving far from your current place to just get some network and doing this session. Being in a car, it really means a lot to all of us. Thank you so much for being here. I think there are a couple of more questions, so it would be great if you can just stay back for a few minutes and just answer if you can, and that would be great. And thank you so much, Gareth, for joining us today. It was wonderful having you.
Yeah, it was great to be here, and I'm going to stick around while I have battery to spare. So thanks for having me, guys. It was great. Yeah, and I look forward to potentially something else in the future.
Thank you so much.
Cheers.
Okay, so that was an amazing session. So after that, we have Sindhura from Azugat. So, Srishit, would you like to put her on stream?
Yes. Hi,
Hi.
Sindhura. How are you?
Hi, Srishit. Hello, Smile. How are you guys?
We're doing great. How about you?
Doing good too. Excited to be on Serverless Saturdays.
We are really excited to have you here. And folks, we have the second speaker for today, and from Azuga Telematics. So Sindhura will be presenting on more with less on serverless. I'm really excited just for looking at the title, and so I've been fortunate to work with her in person firsthand, and she's an amazing techie, and looking forward to listening to all the interesting stories you have for us today, Sindhura.
Sure, Srishit. And thank you so much for encouraging me to do this. I think it's quite a journey in the last couple of years, and really nice working with you. And I think we've built quite a few of these things together. So really excited to share these experiences with the folks and all the serverless enthusiasts. So let's see how it goes.
Awesome. So, would you like to start your session by introducing yourself to the audience?
Oh, yeah. Hi, everyone. Good morning. I'm really excited to see you all on this Saturday morning. So I am Sindhura Ramesh. I have about 12 plus years of industry experience, and I am working with Azuga Telematics as a software development manager. So I really enjoy solving business problems with technology, and that's how I also was fortunate to build an entire enterprise application on serverless, and the last 2 years has been an amazing ride. So I would just want to share a couple of things from that experience and the key learnings and how we tackled some of the problems that you may encounter when you're applying serverless or embracing serverless in the enterprise world. So yeah, that's about me.
Awesome. So, Sindhura, can you share your screen? I'll
Yes.
add it to the stream.
Okay, can you guys see my screen?
Yes.
Yes.
All right. To give you guys a little context about the way I've structured this talk is it's more of it's a journey in the past 1.5 years. So somewhere in 2019 when we decided to start a new product line. So I might give you a little context about what the product is and what we do to just lay the context for you guys so that you can understand better on how we have leveraged or how we have embraced serverless in our application. So yeah, okay, let's get started. So okay, for those of you guys who do not know what Azuga is and what we do, basically Azuga is a global leader in connected vehicle IoT space, serving commercial fleets, insurance companies, and governments. So we have multiple product lines built on a data platform. So in the IoT or Internet of Vehicles scheme of things, there is a device that is plugged into the vehicles that starts propagating information about the geolocation, the vehicle health, the driver behavior, the crash detection, and any other information that it can propagate that it has an access to. So that is gold. Like basically, there are multiple businesses who have a fleet of vehicles as an integral part of their business, and they would definitely want to know how they're operating and how can they operate better. Vehicle is their asset and their liability as well. So how can they probably do things better, and if they have access to data in terms of making their fleets run with improved efficiency, and how do they understand what happened in the fleet in one shot and somebody kind of tracking so that they can dispatch help if there is an emergency or if there is a crash. So there are many such use cases, and Azuga basically helps or empowers many businesses to kind of run better, to operate better, by helping them, manage their data in our SaaS softwares, allowing them to, allowing them to understand and have insights into their business operations, and hence, the ROI that they get is from making some improvements in their business, very small things that go a long way. So we have multiple product lines. Azuga Fleet Management, which is basically aimed at helping the fleet managers to do better, to run their fleet better. Road usage charging, we work with the US governments to kind of give a fair way of calculating the road tax for people with electric cars or the fuel cars alike. Insurance telematics, a lot of people would like to know what the driver behavior is so that they could come up with an optimal insurance plans for them. And finally, the field services, so where people are usually on the road because they're getting somewhere and doing something, and hence they kind of need to monitor an entire user workflow, and that's when field services management and improved workflows to help them manage their workforce, help them manage their work orders come into picture. So this is a little brief about Azuga Telematics, which kind of gives you a foundation of what our business is and what kind of enterprise business are we in, so that when I start talking about the product that we have built on serverless, you have a little context on some of the complexities of the product. So moving on, right? So and in 2019, as I was saying here, field services is something that we started in 2019. So we saw a great potential because most of our existing customers who were on the road, they were on the road to get somewhere and do a lot more things. So just helping them track them when they were in vehicle, or providing them support, or mostly the vehicle centric solution that we had was enough for for a few segments of customers, but it was not for a lot of people who were big on the services. It could be like a plumbing or an HVAC company or a lawn mowing company who basically manages a lot of work orders, who dispatches their workforce to get to a service location, do something, and come back. So you have multiple workflows, and we saw there's a logical extension for the existing software that we have. So that's when we decided to build field services management, extend the features, or build it as a new product ourselves. So when you're building software, this is a very generic thing, right? You have to plan the project. So basically, you need to understand what the business is and how you establish a communication channels with your customers. So it's a very different thing on the enterprise customers, because enterprise is like you're building to help another organization. It's not a direct customer channel. So there is always a parallel communication channels, customer support, and then that kind of influences the software that you're building, and the expectations and the things that you can automate, and the things that, I mean, there's also like a shared responsibility model on the customers or the users who are using the software, and certain responsibility that the software brings. And some of these things are directly influenced by the business goal, understanding how we want to run this business with the enterprises who in turn run their business in a certain way. So when you're running a project, you kind of tend to think about all of these things, which kind of influences each other, and all of these things have to come together in a certain way, so that you can do things in a very optimal way. So the next big thing which you can never ignore is costing. So when you're getting started, there is a lot of things you need to build the scaffolding. I mean, I'm talking mostly about engineering aspects, but before things come into the engineering aspects, you need to kind of define your roadmap. You need to understand how you're going to release some of these things, how you're going to work on this, what's your business processes, what are the teams, how are they structured. Do some sort of a planning before you get into the execution phase. And costing was one such thing for us. So basically, when you're starting out on an MVP, you have a lot of things on your mind. You want to kind of ensure that your budgets are not wasted, and you have like ruthless prioritization on the budgets that you have and how you're going to use it. You tend to be very in your decision making, being very optimal is something very inherently built in all of us, right? I mean, the serverless spirit is also about that. So this was our thought process, where we kind of ensure that we kind of reduce our capital expenditure, operational expenditure before we go to MVP. We understand how it kind of fares out, and then we do an iterative development, and also iterative thought processes. So what is that that can help us work with optimal costs on the engineering front. Then there is the people, where you want the right kind of talent. You want this. There's a certain structure. You need to think about: do you want DevOps? Do you want the application teams? Do you want what's the number of engineers you want to support, so that we can get started and find success in this. And then the process about how do we execute, and what are the timeline constraints that we have, and how are we going to ensure or do the risk management, or alleviate all the risks that we foresee, just to ensure that you can reach your goal within the specified time. And finally, technology. While sometimes we think that it's all of these things are the ones influencing technology, I'd also like to believe that the choice of your tech stack, the engineering, the process facets that you're going to introduce, and the choice of your technology is also going to influence some of these decisions, so all of these are equally important. And while at the phase, you're starting out, maybe the business and the costing and the people aspects are going to influence it a little more. But as you grow and as you are building the software, and once you've built the software, sustenance, maintenance, and how this software adds to the quality or the user experience, all of these things helps in business continuity. So all of these points become very crucial. While we have to think about a few things first and other things next, we cannot leave anything out. So our constraint mostly was like two things at that point in time when we started out. Basically understanding the customer discoveries, like understanding what they really need and which is the feature that we actually start out. Try to define the system expectations, and of course costing, because you don't really want to think about how many servers you need, and what is the cost of those servers when you do not have any business metrics of the load and many other things. So those are things that kind of hog your bandwidth, mental bandwidth, and thought process. Well, actually, you have to be thinking about what is the application that I'm building, what are the expectations, what is the requirements, functional requirements, think customer, groom requirements. So you'll need a lot of effort focused on these areas, and you might really don't want to think about the things that will probably not be needed once until you go on production if you're in the traditional software building world. So these were the two, and of course the fact that the process, the serverless promise, where there is pay as you go, and you do not have to manage the infrastructure, which means I can leverage all the engineering effort in building the applications. And many of these things were very alluring at that point in time, which felt like that's probably a good choice. From these two aspects, the business, the costing, and the operational efficiency that it may bring in. Having said that, what are we building? So while these are some things that those are business metrics, it can kind of help us in, the known benefits, but you're trying to embrace that into an enterprise architecture. And I've not really heard of anybody doing that so far in 2019. It was a completely new territory, and we're not even sure that when we say serverless, a lot of people on the internet or otherwise talk about it as a fast paradigm, functions as a service. But when you're thinking about enterprise software, basically it's an enterprise solution. So what do we really need? It needs to satisfy the needs of another organization, and we manage everything from infrastructure to data, and it's multi-tenancy software. So to give you a little peek into the functional complexity that we experienced or we had in building this software, is you can imagine a workflow. Anybody who's running a business, let's say a plumbing business, basically has somebody calling them asking for somebody to dispatch somebody to fix a leaky pipe. And there is a whole lot of thing that goes in there, which is the customer relationship management. The business is running and they're talking to a customer who's requesting a service, and post that they need to kind of create work orders, dispatch those work orders to their workforce, and have one of these workforce, their workforce, the field workers, go to a service location, manage their jobs, go do a job, and probably upload pictures, take pictures, media uploads. And then you have a complete accounting life cycle where you have the customer pay you. So you kind of think of all these as workflows which are interrelated, because you're building a workflow for a given domain, and that domain kind of says that you finish one thing and kind of leads to another thing. So you have logical steps that kind of the business follows, and you want your software to help them do that better, or nudge them in a way that they don't miss out on any of these steps, so that when they have the data at the end of the month or at the end of the year, they know how they're actually performing in their business. So this kind of gives you a peek into the software complexity, or the requirement, the functional requirements that we had. So the challenges from a system, like if you have a system and then you know that this is the business and you need to kind of mimic this in your system workflows, and it's an enterprise SaaS, so you're dealing with multiple business and a lot of industry verticals. So there is no one size fits all. Everybody do certain things very differently. So there is already a challenge that we have to figure out on what is the set of requirements that kind of caters to that we can put it as a software feature and help them customize it in a way that they can use it or they can mimic their business operations. So that kind of leads to a lot of customizations, a lot of ways that they can choose the preferences in the way the software itself behaves. And you need to have like a web application and a mobile application, basically, because you have people out there doing their jobs. So you need to establish real-time communication between these two channels, who are in the office versus who are in the field, because you need to also ensure that once they are done with a given job, you need to utilize their time and to do another job or dispatch another job. So there comes a lot of things there on route optimization and job recommendations on who is the ideal person to go do this job and many other things. So you're basically dealing with a lot of entities, which are business entities, which are interacting, which are interlaced in a given workflow in a certain domain. And this is very crucial for us to sell this software. And the other thing is, like, you need to have configurable user permissions. Like, you need to, this is very similar to how you would have like an AWS management console, right? Like, what happens is, like, you're provisioning many things, but then you as a user can control permissions or policies of other users, control what each person sees and what they do on what they see. So on a SaaS operation, on a SaaS software, this becomes very important for them to have these kind of flexibilities so that they control what each user in their business who's using the software is capable of doing or capable of seeing. And the software has to be reliable, durable, and consistent, because this is user data that they are coming on the software, logging in and creating a lot of data about their business. So basically, even if you look at it as a bookkeeping, this is eliminating book and paper for them, a pen and paper for them, which essentially means that we take the promise of this to be durable and reliable and basically consistent, because this deals with a lot of system state. So I'm doing something, it kind of impacts something else, or it kind of notifies a lot many people that there is a state in the system and they need to act on it. They need to do something about it. And this application is heavy on the data, because a lot of users who are logged in the system are creating data, and they are kind of using the data in many ways. And there is a lot of long-running queries, which kind of helps them, or extracts the data from multiple data sources, transforms it, and presents it in a way that they can understand, or they can derive how their business is doing. So data is like very important in such businesses, and it's also the data that is generated by our users. So having to run some analytics on that data becomes very important. So that's where the crux of our insights to our customers is. And of course, because we have a web application and a mobile application, people are on the application doing something, and they want that to be fast. So they do not want to wait, and they want things to be really fast, and they want a better user experience. They want things to be done in like smaller clicks. And when you do a click, you want whatever is the operation, right? It could be like some CRUD operations, or it could be many other things that you set into motion. And if at all there is a user waiting on the client, and it has to be really fast, because that kind of influences their decision making of going with one software or the other. So, and then finally, the compliance and data security. I spoke about a lot of industry verticals. So there is, and we are managing their data, and there is also data of many customers. So it has to be, we have to ensure that we manage the customers' data in a very compliant and a secure way. And we also ensure that people do not accidentally, see any other account's data. So within the multi-tenancy, again, you have multiple layers of users who are with different levels or playing different roles, who are further capable of seeing a few things or not seeing a few things. So when you look at building such a system, so these are the things, these are your challenges, and you are already aware of how you do these things in the traditional system. While the only downside to doing some of those things is, you're thinking a lot about the infrastructure, the cost, and other things, but you already have the knowledge of how you build it. And you're tuned in a certain way that this is the way to go about it. And serverless, with a lot of people using serverless as just the Lambda compute layers or fast paradigms, it's really hard to say that while serverless can bring in some of those business metrics, or the gain in the efficiency or the costing, like the TCO aspects, which can be like almost halved or 1/3 of it. While you understand all of those things, when you look at it from weighing these options from a traditional standpoint in serverless, it just feel like, really, can we do this on serverless? So what does it mean if we are going to choose this as serverless? Because it definitely brings a benefit in terms of the cost and in terms of the constraints that we have, and we are not really sure the MVP and what it's going to be, and we need a lot of focus on grooming those features and think customer, and we need everybody to kind of be looking into it and provide ideas. So how do we do this? So while that one is beneficial, there is a lot of other things which are unknowns. So we kind of started with listing our pros and cons and what we can do and how we can go about it. Can we really do this? Is serverless the right choice for us? Because we already have other product lines which are working on traditional systems, and we know how to do things there. Wouldn't it be faster if we go with something that we are familiar with? So these were some of the questions that were running in our minds. So obviously, as I spoke about, when we kind of listed it down, we said pros and cons. So pros was obviously the benefit of the cost, right? And which is a huge influencer when you're making decisions, at least from a management perspective. So the fact that you do not have to think about the servers, it's like deferred decision making, right? That's not our point or the thing that we need to think about right now, because we don't know what we're building and where are we going to run this is the next decision. And having to start with that for us to even have a developer environment was not really a priority for us right then. And then the fact that you have to think about what is the cost, and is that cost justified? Are we actually supporting the application development for the cost that we have? So something didn't add up. So we said, okay, these are the benefits. The capex, the capital expenditure that we get started with is absolutely justified, if you're choosing serverless. And the fact that, when you're putting up a team, you have to think about DevOps from the very beginning who can help us with all of these things. That's another point that it means that you need to hire a team. It means more expenditure. It means a lot of things. And it's also not required from the very beginning, where we are still figuring out what are we building and what are we prioritized to build among the bunch of things that we have to build. So this automatically means that there will be a focus on the application development from the engineering team, and you do not want a big team which is focusing on multiple aspects. We have all hands on deck, and we want the engineers to really understand customers, to really understand what the software is, so that they can efficiently translate those things into the software expectations. So the serverless really won there in terms of having to think about what I really need to think right now, and then, as I said, the iterative decision making, right? So I do not need to really figure out what kind of containers that I have to do, the scaling aspects, or even to get started with what is the minimum requirement of your compute, of your RAM, and the machine images, and many other things that you need to decide. And then the cost that comes with it, even when you do not have anything running on it. So we wanted to see that I think these are the strong areas, and we said, suppose we go with serverless as a choice for our software development. What are the things that we do not know, and what are the things that we are skeptical about? First thing, I think it was new, so there was a lot of things that we did not have from when you kind of start searching on the internet, when you're trying to understand if there has been any use cases. But we do know that because of this cost benefit, probably it can translate into a better pricing for our customers, which essentially also means that we are winning on the business front, in comparison to our competitors. So we have a lot of things that influences and pushes us to make this choice and go serverless. But does the developer experience or the engineering activity and the tech choice as such, would it be supportive of some of these things? Because we saw what are the complexities of the system, we saw what is the what does the application warrant. Would we be actually able to support all of these things with serverless, or does it mean that we have to go in a hybrid model? So what do we do? So the things that we were still learning about serverless, it kind of had a transition from I don't think we can do things in serverless to kind of can-do attitudes with each of these things, when we started picking each of these things and started deliberating on that and said, how can we do this? So some of those things was the first concern where everybody talks when you say it's serverless, you go on the internet, is cold starts. So cold start is like a new territory, and a lot of people think, okay, what is serverless? Does it mean that there are no servers? No. So what do you understand about cold start? So you need to understand how probably our cloud support or a cloud provider runs all of these code for you in the containers. So basically, that knowledge of what is cold start and how cold starts creep into this and why does it and how can we alleviate some of those things was very foundational for us. So the first problem that we said was like cold starts. How do we tackle that? We don't know. It's an unknown area for us. And then distributed workflows. So if you're building, so everybody said fast. So we were looking into how we can build or define those structures. So if you're looking at independent functions stitched together in distributed workflows, it could mean a lot of things, right? Some of these transactions have to be atomic, like what really happens when one lambda fails, or you have like a group of lambdas, which I think is not really serving the purpose, because the first thing they're saying is the cost, but you have many lambdas are in scale, we don't know how it performs. So how do we handle these distributed workflows? Because some of these distributed workflows might also mean that there's a client waiting on it. So does it mean that it does mean there are timeouts? So we have constraints on API gateways that it times out in 30 seconds. So you have to get the data or the response within 30 seconds. So does it really help? Because some of these reporting aspects that we may have long running queries in the background. So how do we ensure that the basic need or the functional requirement is met? So there was a lot of gray areas there. So we said distributed workflows, achieving that with serverless is something that we do not know. The next thing, data. Data is something very important because majority of the times our users also use our application as a as a bookkeeping software. Instead of writing it on a pen and paper, you record it here. It allows you for efficient searching, filtering of the data in different various access patterns. So and then there is a lot of data that is also schemaless, where you're trying to be read optimized. You want to know because those are your reports. So you're bringing in data which is of 1 year old, which is all archived. So and you kind of run some metrics or some analytics on it and say that this is what it is. Look, this is what it looks like, the report that you're looking for. So basically, you're working on a lot of data, and both relational data, because it's all transactional information that our customers are generating for us, and also schemaless, where you have the other aspects of data which is like object store, which really do not have to be in a certain schema, in a certain relationship, and each user generates the data in a very different way. So we didn't really know. And of course, if you're in a completely serverless world, the first thought that comes to you is DynamoDB. And so most of our data is a relational database. So we really need a relational database. So how do we ensure that these CRUD operations are built in such a way that it has data interaction at the core of it for every REST call that it makes? Then the fact that the community support or the minimal adoption, it was still growing. It was in a very nascent years, and a lot of these things are still ideas. And on the internet, we are not finding much of a documents. So how do we do some of these things that is very crucial for an enterprise apps and companies which are building these things, which set processes, and you need to be really fast. So does it actually bring the promise of serverless development is faster? That's a question mark. And then multi-environment setup. While we know that when you're building your dev environments, your staging QA environments, or your productions, it adds to cost in the traditional environment, but you at least know that there is a lot of these things set up. So how do we do some of these things was unknown to us at that point in time. It seemed like, how do you manage your stack? Like, I understand that, you do not have to worry about the infrastructure, but you still have to figure out a way that you control the infrastructure, while someone else, the cloud provider, does that for you, managing the infrastructure. But we need to tell what needs to be done, and that needs to be done on multiple environments. So at that point in time, when you don't know some of these things, it felt like, is it really feasible having to manage all of these things, multiple stacks? And there will probably be some changes in the stacks depending on the environment that you're running in. How do we manage that? Stack management, when you only know about FAS, was another big challenge for us. Then the aspects of contextual troubleshooting, because these are distributed workflows, which essentially means that when you have an invocation on a Lambda, there is a lot of things that it sets in motion. So when you're looking at something failed, or when you're looking at something went well, or you want to really understand this is taking longer time, so where exactly is it taking longer time? Which is the downstream service, or which is the microservice that is probably not doing well? So you need to understand some of these things, and it really felt like having insights into those distributed services or with the CloudWatch for every Lambda invocation doesn't give you a picture of contextual troubleshooting. I want to understand what happened with an invoicing. And the invoicing has multiple Lambdas and multiple queues and topics and many other things. So how do I really know what really happened? And how do I stitch those things based on the timestamp, right? I go here and then I say, okay, there is this Lambda that is invoked. The other timestamp on the other Lambda, does it actually mean that it is the same invocation? How do I figure those things out? How do I do some troubleshooting when there is a customer reporting a bug, or when we report a bug? So how do we figure out what really happened in our code? And yeah, I covered the infrastructure stack management, and what does it mean on monitoring and performance at scale? So basically, we know that these are the benefits and these are the unknowns, but does the benefit translate into unknowns or things that we are not aware of when these things perform at scale? Because there is no data, or there is no use cases that we have heard from other enterprise companies who have embraced serverless. So how do we do all of these things? Having said all of these things, it felt like it was really worth it to try some of these things, because the gain that we may have from a costing perspective, when we were very uncertain about the functionality and how our MVP is going to fare in the market, this really felt like it's an opportunity for us to go ahead and explore it, because there is a lot of other engineering companies which are talking about it. So I think we need to explore some of these things firsthand and really validate for ourselves if these things are doable or these things are not doable. So at least then we have some learnings that we can share with the community. So with this thought process, we started to pick each of these things which were unknown for us, and got started with figuring out how it's possible and how do we kind of align some of those things to our use cases. So the first thing is data. Data is the soul of any system, right? So and especially for us, when I'm talking about reliability and durability and data security, it's because your users are generating a lot of data when they're logging in every time. And they may also want to know how the data has matured over a period of time. So, and then we don't know what are the choices that we have, and how can we connect a compute layer to fetch data from the database. So the first thing, we needed a relational database. And at that point in time, we chose Aurora Serverless on MySQL. And we only had 5.6 support in 2019. So we said, let's get started with it, because everything at that point in time for us was POC mode. While bringing all of these things together was very fast, very easy, because of the documentation and other things that were available to us. But the fact that you didn't know something and you have to figure out something is something that we had to battle every single time. And that also, over a period of time, changed the mindset that we had towards how we approach these software development paradigms. I'll come to more of that later. But here, when it is data layer management, we kind of want to understand that we have a traditional MySQL, so people are used to thinking of it that way. So what does Aurora Serverless mean? I mean, what do we have to do? Does it mean that the DB also is going to have a cold start? And that would be catastrophic, because while Lambdas having cold start is one thing, having your DB sleep and bringing it up probably could be a whole different thing. So each of these questions that popped on our mind were something that had to be addressed. So the first thing we said is, let's see how we can bring up Aurora Serverless, and what does it mean, and what is our compute units and the memory tuning that we need to get started with, and understanding how the pricing and everything works around it. So we did some of those things. And the next thing is, say we have a compute layer and compute layer itself is like a question mark for us, right? How do lambdas become a compute layer, and does it mean it's just fast, or can we actually build microservices on the lambdas? So once you figured out that this is an opportunity for us, and then you need to figure out a way for your applications or the compute layer to communicate with the data, because every single REST operation that you're initiating needs to interact with the data, either write the data or get the data. So we need a way for us to manage some of these things very in a very optimal way. And also, how can the developer experience can be suited, because you're talking about data, there's a lot of security encoding that would be there. How do you decode, how do you fetch the data from the service? It makes a lot of difference. Are you fetching it as a JSON? Are you fetching it as a double array? How do we do it? How do we manage connections? How do we open a connection? How do we close a connection? So some of these things had to be like something that is crucial for us on every calls. So we figured out that I think there is a data API client which can help us do some of these things. So let's get started with some of these things and say, okay, it can help us with IO operations and management and data up to a certain extent, and we can take it from there, from the application layer. And we also had many requirements where you would want to, you wanted read heavy operations, and it has to be read optimized, because you really do not have that much time, right? Like it has to be blinking fast. So in those cases, to manage some connection stores, to use some of the data as a cache layer, because DynamoDB is like really super fast when it's working with Lambda, because it's in the same ecosystem. So we started to kind of decide what is really relational and transactional. So it kind of also pushed us to think about our product, about our domain, and about the features that we have. So it kind of, the technology or the serverless aspects kind of pushing us to think, how do we do these things, which also means that I'm thinking about optimal solution in every single step. So this was our challenge, and we decided to get started with this and see how it goes along the way. And the second thing is, when I'm thinking about all of these things, how do I manage the database? We know how the DevOps manages the database in a traditional world. So you have an RDS, or you have Aurora, which is a managed service for us. But still, there's a lot of things that they do in terms of software updates or MySQL updates, if it's your regular RDS, as opposed to your managed service. So what really happens? How do I mean, even though it is serverless, there's someone else managing the service for you, but you need to tell them what to do and when to do and how to do. So this was actually a challenge when you're thinking about, say, 50 plus lambdas, and out of which probably 20 or 30 of them are your microservices, and that's how big your application layer or complex the application layer is. So how do we manage all of those things? How do we manage SQS, SNS, and every other thing that we would be using in the infrastructure? So that's when we started on the serverless framework. So this kind of shifted the mindset for everyone, because it seemed a lot more doable, right? Where you're just thinking about infrastructure at one level, the topology aspects, and then you're trying to say, how do I manage this? And here's the key for you to manage this. So basically, when you're looking at the serverless framework, it took care of most of our infrastructure as code heavy lifting, and it made it very easy to define and deploy our stack. So how do we do our CI/CDs? How do we automate such complex stack deployments? And at the time we started, the cloud formation had a limit of 200 resources. And it was very surprising that we fast forward by a few months, we actually hit the 200 resources limit very soon into our architecture. And by then we got started learning on the split stack to see how you can actually split your stack based on how it is used, how often it is deployed, and how often the code changes are reflected in the stack. So it kind of allowed us to think about these infrastructure also in a very structured way, in a certain thought process, which was very, I would say, in the way that we would do our release processes. So it kind of influenced how we do our release process, and hence how should we define our stacks, and in turn learn from how these stacks are deploying. So how do we manage these serverless YAMLs, how do we define them, how do we organize them. So each of these things was influenced by the way we understood how the serverless framework does the stack deployments. And it also kind of solved that confusion for us on how do we manage multiple environments. So you need to have like a development environment because you need to have your UI basically talk to the backend. And while there are multiple micro teams, the best of microservices is that, as Gareth mentioned, I think it was really encouraging to see Gareth talking about some of these best practices. And it was also a validation that we have used some of those things. And it was really encouraging to hear it from him as well. So it's more like you have multiple environments and you have all of those questions in terms of how you can manage each of those stacks. And it also was easy because your environments are also pretty stable, and it's also the same, right? A lot of traditional architecture, we try to optimize a few things on our development environments or staging environments because it's not really production. So you really don't want to be paying some of those costs that you would pay. And let's say if your downstream things are in a certain way, you're trying to mimic some of those things, and sometimes you may not be able to test your architecture, the design completely before you go to a production or an environment which mimics the production because of these costs and other things. It kind of helped us do all of these things because we set up multiple AWS accounts. We had these development, staging, and production stacks, all of which are very cheap, and it's not adding to our costs at all at the time when we got started. And we also know how these things are done in development stages, and we are involved in deploying these stacks, which also gives us confidence in deploying those stacks on production by the time we hit production. And continuous integration and deployments became very easy because it's also very secure. The serverless framework allows us to have these IAM roles, and it works well with Jenkins and any other GitLab or any of those CI/CD tools that we were using. So the stack deployment, which was a very big challenge for us at the beginning when we started with the traditional development mindset, became a very easy thing for us. And once we built the scaffolding, it was just a matter of adding features and introducing newer microservices and getting started with it. So this is something that really shaped and gave us a lot of confidence in going ahead with serverless from a developer experience as well as from a business goal. The third thing is like the application tier. I spoke about distributed workflows and many other things. And it also kind of understanding how Lambdas work also influences the choice of your programming language and what you really need to do, because every single thing that you think about Lambda is about cold starts. What are the things that you have in your control to bring down your cold starts? So obviously certain languages increases your cold start, because if we were comfortable with Java and other languages which we were already using. But let's say if you're choosing Java, it's a compiled language. So what happens really in Lambda is when you invoke a Lambda, basically that compute layer gets deployed on a shared resource. It comes up, does what you ask it to do, and it goes down. So automatically when you're having a compiled language, it also introduces that bytecode translation and those nuances, which might also increase our cold starts. So obviously our choice of language was influenced by some of these things. So we said we are either going with JavaScript or TypeScript for developer experience. And we said, okay, let's get started with Node.js Lambdas. And most of the things, I think Gareth covered a lot of these things. It was very interesting. So those are some of those things that we applied at our application layer as well. And we embrace domain-driven design. So that also warranted each of the engineer who's working on this to think customer, to understand the domain completely and see how we can mimic those workflows in this system, what's kind of event-driven and what is actually something that needs to be in real time, and there can't be any lag. Understanding some of those things really influenced the way that we defined microservices. We kind of also understood what is even at the code layer, not just at the functionality layer. at the code layer as well, we had an understanding of this service needs access to all of these codes. So how do we ensure that while we keep the lambda size very optimal, so that bigger size lambdas does not add to your cold starts. Also, we ensure that whatever, keep only what's necessary, plus whatever it needs for its working is also available to it, and it doesn't have to go with invoking another lambda, or that lambda invoking another lambda where it's not event driven. So it kind of influenced us to think packaging, package size, assign clear roles and responsibilities for each of the lambda, which is actually working as microservices for us, and what are the responsibilities of each of those microservices, and how can we leverage what is an optimal package size. So we decided to go ahead with the concept of pre-shaking, which allows us to manage that code very effectively when we are packaging them as microservices. And although we have like a shared database, which is our transactional database, thinking some of these things really influenced us in a way that we understand the customer needs and the each responsibilities of each microservices. And basically, for the microservices, you kind of the push towards going domain driven was a paradigm shift, because otherwise you're not thinking about the compute, you're not thinking about how fast your code is running, because many of those things are taken care of for you, and until you go ahead and see how the RAM is being consumed or the CPU is overloaded, you really don't think that there's any problem with your code and other things. And the latency is just a choice, right, at the developer layer. But here it kind of pushes you to think like that. And because also the API gateway has a 30-second timeout when it is invoking those lambdas, you automatically tend to think that your even your longest running queries or longest running operations cannot be beyond 30 seconds. So it kind of pushes you to think and optimize at each of these layers, allows you to leverage each layer, even what can you do at the client layer, what can you do at the server layer, and how can it be asynchronous, how can it be distributed, is it really necessary at this point in time for this operation to take place, or can this be decoupled. So these are the things that kind of pushed us to think very differently on the architecture side. So we totally embraced an event-driven architecture when there were scenarios or test cases, use cases where there is one operation and that operation leads to a complete change in the system state. And we had to keep the system state consistent, because what somebody from the mobile app is going to generate the data that goes through a lot of processing, and the person who's actually viewing this as an admin needs to understand what is happening. So there is a lot of ironing, there is a lot of tuning that we do on the data. So, but then how do we do some of those things? How do we ensure those workflows are mimicked and the data goes through the pipeline? All of these things were a change in the thought process for us to say this is the approach that we are going to take. So it totally led us to embrace an event-driven architecture or domain-driven design to understand the impacts, to understand how a user is actually using the system. So it was a win-win for us, because the developers are thinking how the customers are using this. The product is thinking, how do we want to have these responsibilities on the system as against the other communication channels, and the customer is happy. So and then the next thing for us was, we deal as it's an enterprise applications, we deal with a lot of integrations, payment gateways, or say, for example, you have other accounting softwares that our clients are already using, and they ask for if the data could be integrated with those things, or we expose a few of these things as web services for different clients to have push data into our system or consume data from our system. So all of these things warrants that we manage all of the access keys, partner keys, API keys, secrets, everything very in a secured manner. We don't have any of those things at the code layer, so that it's not breached or it's not misused. And you also sometimes have environment specific variables. You have a sandbox environment for your integrations, whereas you have like production environments. How do you test some of those things? So so we again got started with how we can do this and what are the best practices that we can apply. So we use AWS Secrets Manager, where we store some of these information so that it's kind of abstracted from the person who's coding, where he again needs to focus on the application, where he just needs to store some of these things. And we have the serverless framework do all of these things, access those things via the IAM roles, get that data and make that happen for us. So there is security, and there's also abstraction, where you don't have to think about these things every single time you're managing your code, and there's no accidental mistakes or somebody misusing some of these information as well. So as I said, that once this pushed us into all of these things, you also start looking at all the available layers in a multi-tier application as things that you can do, things that you can leverage. So what can you do at each layer? How can you be more optimized? How can you be more efficient in each of these layers? So that's when we had this. A lot of client-side compute is probably not being used correctly. So can we do something there and have some of these complex HTMLs and other things? And also most of our customers are using Windows or tabs or many other old devices, where that essentially means the experience that they are going to have of our software also to an extent depends on their compute device. So how can we alleviate some of those things, and so that we do not even put the load on the server, but at the same time the end user has a better experience? So server-side rendering was something very interesting that we found. So we decided to go build our UI on React on the Next.js framework with the SSR capabilities, and we use Vercel to deploy the lambdas at edge deployments. And basically this helps in reducing the compute load on the device, on the browser, irrespective of the browser that they're using. It kind of just dishes out the HTML. It also introduces a certain level of safety to the users, because when you kind of inspect, a lot of those things is also abstracted. So you can also have some leverage in terms of what are the information that you're passing around, what really happens behind the scene when your UI is rendering. All of those things could also be leveraged with having lambdas at edge, doing all that heavy lifting for you, keeping the control with the application to the most extent, and not having the browser or the client device dictate a few experience terms. The last and the final thing is, as we started building it, we started testing it, we also needed to understand how do we read these information? How do we ensure that we increase the developer experience, so that anybody who's troubleshooting, everybody is providing a production support, finds it easier to understand what is the mistake and where is it happening, so that they only have to focus on how do I fix this, and not break their head on how do I figure out what the problem is. So this becomes very important in your developer experience. So we kind of understood how the CloudWatch insights and alerts could be leveraged for all the 400 errors or 500 errors where there is a developer problem. And we also went ahead with using Lumico for contextual observability and some statistics about our cold starts, about the number of invocations that we are having, which is the most used microservice, most invoked microservices, so that we could do our Lambda tuning and performance tuning much better with some business metrics. So this kind of completely gave us a solution. And as we started working on some of these things and encountering some of these steps, we decided to figure out how these things can be done, because every single time we crossed a barrier, every single time we figured out how to do this, there was some sort of the thought process that has changed, which is very encouraging and boosting your confidence to go ahead and figure out. And then if we have solved these problems, there definitely must be a solution for the next problem or the next issue that we encounter. So with that kind of a mindset, when we changed our this one to a can-do attitude and started figuring out how these things are done by like abstracting out a lot of those things, generalizing and understanding the fundamentals of infrastructure, the topology, and how the developers interact with these things and how they're interlaced, it kind of gave us many ideas and a lot of benefits along the way. And today, as I look at the complete architecture that we have, we have Node.js lambdas that are exposed as microservices via the API gateway. We are using API gateway in more than one ways. We have a custom authorizer layer that basically talks about when the person is invoking a REST API. It talks about whether this person has the permissions to do so that our endpoints can be secure, which can also be leveraged for web services, right? At the client layer, it's much easier for us to figure out who's capable of doing what, but we usually need to have that at the server layer as well. So we have our custom authorizers that we have defined, which works very well with the API gateway. The API gateway takes care of the routing. The API gateway takes care of the error handling. And so the controller layer that we may have in our code is much simplified. It becomes, for the developers, it's just a thought process of the multiple layers that they have to introduce, the business logic, the data layer, and the controller layer. And most of the focus of the code quality and other things, it allows or encourages the users or the developers to use this, while majority of the heavy lifting is done by API gateway, which is like an endpoint for our microservices. And we have Aurora Serverless, as I spoke about, and the DynamoDB at the data layer, which basically interacts with our lambdas via the data API client, which also allows us to manage the connections. So that we do not have the fear of, if the lambdas scale up, would that actually overwhelm the database, or would it not? So how do we ensure that the database also scales, and how do we ensure that there are no issues of IO operations or unclosed connections? All of those things are handled, and we can be kind of rest assured that you focus on the logic and ensure if your logic is right, your query is in the most optimal way. We do not really have to worry about all of those things, and hence monitoring that. So we have AWS SQS in a lot of places, in a lot of ways, where we are using that to decouple and scale distributed services. And all of these things, obviously, with the benefits of microservices, right? So these things go hand in hand. It allows us to also have distributed teams, micro teams, focusing on those features, and kind of shipping out the code faster. And we are using EventBridge extensively in many of the use cases that even Gareth mentioned. So you have transactional data where the write happens, and then it kind of sets into many things where you can build some denorm aspects out of that data and have that ready for when the data is read, so that the queries that you're running is not very complex. It already has all the data computed and available in one place. So it just becomes a matter of select statement, and not multiple joins, and not multiple data ironing that you have to do. So we have used some of these paradigms or patterns very extensively in our architecture, so that we know what are the operations which are read intensive, which has to be faster, where the data needs to be available, and what are the operations that has to be almost in real time, where we actually have to compute it via the joins and the other things in MySQL every single time. So we know how our system is working, how our users are using it. So it automatically pushes us to make some of these choices every single time that are the most efficient for the given use case. And we are using SNS for push notifications, for communicating with the servers. You're using SNS topics effectively. We have queues and topics where we have to broadcast, or for the pub/sub models that we may have, which is also required for the event-driven architecture. Also to trigger emails, so that our tenants have a way to interact with their customers via SES. We have Amazon S3, which is using for media store upload, where allows us, the users of the application, to record their documents, record their photos, documents, videos, whatever they want to use it as a store. So it's not just limited to the data that they generate. They have all kinds of data that they generate. So that's working out very well for us. And obviously, we have CloudFront Certificate Manager, which helps us for deploying our code or push notification services, which needs to understand the iOS or the Android certificates for deployment, talk to the mobile phones. the Secrets Manager, CloudWatch, and many other AWS services that we have. So, and then we have, and the cost. So now with all of these things, what are the benefits, and how we have kind of come to realize the benefits in an enterprise application. I think we're already 2-3 minutes above the time, so I'll make it really fast. So the cost to serve. So we have some data now to say, okay, this really is our cost to serve. So we have like 50 plus business accounts which is using our system today, with 600 plus system users, and our monthly infrastructure cost to serve is less than $900, with say close to like lakhs of transactions or lakhs of invocations that is happening. So transactions, lakhs of Lambda invocations, and the amount of data that is going back and forth from the system, the computation. So in comparison to if we were on the traditional system, at least this is 1/3 or maybe 1/4 the time that we would need to operate at this scale. And also our development environments, which is not the production ones, is less than $500 per month. Otherwise, you have to bring up all those things on all these environments for us to kind of mimic it and have ensure that the quality is maintained before we move to production. And we do not have a DevOps team right now. We kind of understand some of these things is ingrained in the way that we do development today. But then without having to understand and go deeper on the things that I really don't need to know. So there is no DevOps team for infrastructure managing. So obviously there is a gain on the cost there. Without a dedicated team doing that, and also the pay-as-you-go model is serving us right at the MVP phase, and we have now moved past the MVP phase, and we're at the customer adoption phase. And I gave you a little stats about the number of accounts and the system users that we have, and the cost, the infrastructure cost that we are incurring, or the operation cost that we are incurring to do the same. And when I'm talking about easy operations, it's more like, we have faster release processes. So most of our release is actually driven by the dev teams. At the end of every sprint, we go live. So it gives us a lot of agility in terms of how fast we are moving to production. And it's zero downtime, as against like you have to deploy and restart your EC2, or you have to bring up some of these things in a traditional way would warrant a few steps. But these are just a matter of deploying your stack, and you've already tried some of those things in your dev and staging environment. So you really have figured out if there are any issues, and you have eliminated all of those things. So you have zero downtime. And even if there is any error there, it's very resilient, it's cushioned, and it's just limited to that microservices. While this is a benefit of microservice, serverless makes it even more beneficial because it brings another layer of abstraction. You don't really have to worry about the infrastructure or something going wrong. It scales. And then it's also cushioned, like if your one service is not working, and you can figure that out on the application monitoring, because you have a lot of data and metrics about the time, if it's timing out, and the RAM consumption and the bill that it generates. And the performance tuning also becomes very faster because you're thinking application. The only problem that the Lambda is not performing would always be you have not done something right. So there is a problem in the code. So it automatically becomes very easier at some level to go and figure out where the problem is and how do I do it. And also if I'm seeing that there is a problem with the way or the latency of the application, it also gives us a very easily and faster way to just tune your Lambda, increase your RAM, and increase your memory, and it directly will have impact on the next invocation, on how faster or how your customer perceives this operation. And I covered the developer maintained and the cost to serve. And our release processes these days is like probably 30 minutes thing, where we have already figured out what our checklist is, what our features is. We've tried that on our staging environment. Everything is working. So it's just a matter of merging your code and deploying that stack, both on the front end and the back end. It kind of makes it very easy. And the developer team is doing that brilliantly well. So from a developer experience and productivity, I think for any developer, he needs the more productive he is, it's better for the business. He's able to drive impact with the knowledge that he has. He's able to drive results. And also the experience wise, there is a lot of things that the developers do apart from coding, which goes unnoticed. And if we kind of can automate a few of those things, if we can make sure that those things are taken care of in a certain way, automatically it leads to productivity and also happy developers, where they can also focus on a few other things and not worry about some of these mundane things. So how has that helped in our in serverless for us in this product? So from a productivity standpoint, faster development cycles. I mean, the idea to production is really fast, and there has been situation when we got started that we've worked in 1 week sprints. That's like highly agile, right? So, and it's. I think serverless has optimization at the core of it. I mean, whether it is infrastructure resources or whether the way it pushes the people who's working on it to kind of work on the optimization aspects and improve decision making, prioritizing the decision making. So it has helped us to have faster cycles from idea to production, because every single thing is automated, and the problems that there may be can be figured out with the right choice of tools, and the understanding of the developer himself, and the domain driven design that the serverless pushes, and the application focus has also enabled us to have dev owned QA aspect. So we've worked in dev owned QA, while a lot of these things depends on the engineers capability, project facets and processes. I also would like to attribute a little of these things to the tech stack and the choice of technologies that we are using, because it changes the way we think about software development. And it allows us to understand what are the things that can be automated, what are the things that can be mundane, and what are the things that needs to be in the control, automatically increasing the productivity of the developers. And we have like ninja teams, I would say, because micro teams, which is working on different tracks, shipping code at a very fast rate. The velocity is really high, because, and also the quality is really high, because the engineers are able to think customers, because you're kind of taken care of all their scaffolding, and it's a matter of building some of those things. And even for the newer engineers who join the team, typically it so happens when the teams grow, your productivity comes down, because there's a learning curve, there's a lot of context that is not there. You have to maintain some of those things on where the infrastructure is, how do you debug, and many other things. But all of these things is in the code, as infrastructure as code. So it becomes very easier for the newer engineers to kind of wrap their head around this concept, and they have access to all of these things at the code level. And that essentially also means that the developer interactions are very limited to the application that you're building, in understanding the application, and allows time for interactions with the product managers, removing the otherwise interactions that we may have with the fellow developers and other counterparts in the software development process. And this has really proven to be beneficial for us, even in the remote working environment that is there now, due to the pandemic and many other things. And from a developer experience standpoint, the learning curve is amazing. Does it mean, I believe that I think this is truly full stack, because when you say full stack, you're thinking front end and you're thinking back end. But unless you realize how these things are deployed, you're not really a full stack engineer. I wouldn't say full stack, but you're not really knowing some aspects of it. And while all of these things were always treated as a separate thing, where a DevOps is treating all of those things, serverless kind of allows you to understand some of those things and help that allow those things to influence your decision making at the code level to optimize a few things, while it also abstracts away a lot of infrastructure related things that you may really not need to know. And also the way you do things with infrastructure as code and other things is more of, you do what you do best. So you know to write code, so write code. To write code for anything, to do anything, do that. And we have a way to understand those things very easily. So you can do that, while a lot of the other things was done for us. You just, a matter of writing the code in a way that what needs to be done, just like the way we do at the application layer. So this has improved the experience of the developers, where there is an initial learning curve. It essentially has had gains in the speed of development and the throughput of each and every engineer working on it, with a complete understanding of how software development works. So, I mean, this is like a little trivia here. So this is something how our commits look like every single sprint for the past, I don't know, like for the past 1+ years. So if you see that, everyone, all of these things are functional commits, the code commits that we're seeing. So the development team, whether it is the Ninja team that we started with and the way it has grown to now, even with the size of the team that we operate with today, the microservices and serverless has kind of helped us to ship more code on the feature side and build the product that it is today and move past. And it has helped us build MVP in like about 6 months time and move to the customer adoption phase very faster. From a technology supporting the business standpoint, this has been a huge hit. So from a closing points, what I would say is I'm not saying that serverless is like a one-stop shop and it's the solution for everything. It's more of how we kind of change the attitude to embrace serverless. And we as a team are still working on it. So do we have something that we don't know how to do on serverless yet? Yes, there's a lot of things, and that the system is also evolving, and we also are evolving as a team. So, but from a key takeaways, the reason I also called this discussion or a talk is more with less is, the serverless allows you to think very minimalistic. So you do I really need this? No. Do I really need this? Starting from your infrastructure, but how can I do more with it? How can I, at every layer, at the time of process, at the time of people, at the time of development, with it kind of pushes you for a paradigm shift in the way you approach software development. You need to understand or go domain driven, event driven architecture. You need to understand some of those protocols or the contracts that these services expose. But once you do that, and once you know how this is done, it's just a matter of stitching some of these things in a way that kind of caters to your needs. And from a monitoring and observability standpoint, which becomes very crucial on the engineering for all the engineers, we move from infrastructure monitoring to application monitoring. So you're really not thinking about RAM, CPU, and what is the memory or the heap, or you're just thinking about applications. So basically, you're just spending very little time on some of these things, which otherwise would be a full-fledged task about monitoring your applications or auto-scaling them, auto-descaling them, something going wrong and leading it, and a server goes down and leads to non-availability of a service. All of those things are eliminated, and you kind of move to application monitoring more than infrastructure monitoring, trying to understand the latencies of your API calls. Is there a 500 error? So what really happened? How can I fix those things? You also have all of those information available to you right firsthand. So that kind of helps the developers also when they approach a problem. They know what the problem is. They don't have to spend a lot of time figuring out where the problem is, what actually led to another problem. So it's more about their application that they have built and they know it. And system resilience, because even if there is a problem, as Gareth also mentioned, it just scales. You might have a fat bill at the end of the month, but then it doesn't lead to non-availability. And even if and also with the microservices, the approach that we have taken, one of the Lambda fails, but it doesn't really mean that the entire application failed. In the way we have also packaged the Lambda, it's just that one of the service that is having an issue, and the impacts of some of those things are very cushioned. So the customers don't feel that the system is not working, or the system is inconsistent, or the system is non-available. And also, in the last 2 years, we have growing confidence in the serverless community. I have been fortunate to work with two AWS serverless heroes myself, Sushit and Prashant, from India. So with the serverless communities growing, I think there is a lot more confidence and a lot of people embracing these things. There is a lot more ideas in how we can solve some of the problems that we encountered. And you have increased operational efficiency, reduced total cost of ownership, as I spoke in the last couple of slides, and obviously the developer throughput and the growth or the learning for the developer to really have an entrepreneurial thought process in terms of from a technology standpoint, understanding all layers, including the topology, including the infrastructure, only the things that he need to know by abstracting out the hardware aspects. Having said that, there are a lot of other things that we are in right now in our software development. We are trying to figure out how we can get metrics on system performance under load. So while we are at lakhs of invocations on these services, I'm talking invocations, not the QPS or any of those transactions. But when there is a lot of these things, how does a given service scale when it's like under load, when I have millions of users probably logging in and figuring out how does these downstream services work? Well, the lambdas and other things might infinitely scale. But how do we figure out some of these things is something that we are focusing on architecture. And how do we build performance test suites? What are the frameworks and tools that we have available at our disposal? How do we leverage some of these things to further, make this enterprise product a success, even under load? How do we scale? So this is a continuous thought process, a continuous learning, iterative decision making, iterative development, iterative at every stage, but also trying to keep it minimal, defer the decision making that you don't read right now. So with these things, the work is also very enjoyable, and it's really nice to see that there is an entire enterprise app that has shaped up on serverless over a period of time, and it also has given us the knowledge of what are the fundamental things in software development. How can I abstract those things? How can I understand the generalization and open my mind to doing these things in a certain way in Java, or doing these things in a certain way in Python or any other stacks, as opposed to doing this in serverless. It's the same thing at the application layer, but it probably has a little more generalizations that you understand, which makes you a better decision maker. And also the specifications. You also have what are the things that don't work, and so you know what are the choices that you need to make. How can you ensure that these things play out well? And set you up for success at the technology front. Yeah, so that comes to the end of my key learnings that I wanted to share with you guys.
Hi. So thank you so much. It was a really insightful session. I personally learned a lot of things, and I had a lot of questions running in my mind regarding serverless and software development. You cleared all of them. So
Thank you,
we
Sim.
have couple of questions in the chat section also.
Okay, what is the single biggest challenge you and your team has faced in adopting serverless so far? I think the single biggest challenge, I wouldn't say single, but the foundational biggest challenge that we typically face is a paradigm shift, the unlearning curve that comes with it, for us to kind of understand what are the questions that we need to ask. You ask the right questions, you find the right answers. So for us, it's mostly been that. And once we are slowly, because that takes a lot of time, because it's a paradigm shift, you need to unlearn a few things and relearn a few things, and then you need to understand and compare the two learnings that you have and say that this is exactly the problem that I was trying to solve, and it's solved this way in this stack, whereas it is solved this way in the serverless stack. So this, I would say, is a challenge that we have, and we are slowly overcoming that challenge. And all of these things are becoming very easier for us, because if there is some infrastructure side challenges, I think that kind of depends on the cloud, and how faster they make the releases, and they enhance the solutions. But until then, how do we uh, how do we solve the problem with the resources that we have is something that pushes the developers to be making choices every single time. And we do that every single day in everything that we do. We just don't give it enough credit. Like, we are always looking at developers, coding, and application, and many other things. So that, I would say, is the biggest challenge at a philosophical level, and that is something that the team is overcoming with every sprint, every releases that we are making. How much worried are you about your data when it comes to serverless? So no, I think it's kind of given increased confidence, because even Aurora serverless, we have data layer encryption, and our rest is HTTPS. So the data in rest and a data at the storage layer, both of these things, I think, has no impact whether you are using serverless or you're using any other stack. You need to bring in some of those security measures anyway. And all the infrastructure side, we already have those support. And we also do run all our stack inside our VPN. So basically, there are multiple layers of security that there is. And even as I said, we are using lambdas at edge. So even whether it's password or any other information that we are passing, we are ensuring that there is no way that there could be SQL injections or people having access to some of the data that they're not supposed to have. So with lambdas at edge, some of these things are also taken care of, where a lot of people do not understand how exactly these things are running, because all they see is HTML that is rendered at their client side. So with some of these things and enough compliance measures, and even S3s are encrypted, so that whenever you're accessing or uploading and downloading in S3, it is kind of encrypted, and there is a certain level of security that is brought in. So with this, I'm not really worried about the data per se. And even with the way we kind of handle the data API client and other things that we're using, we've taken enough measures to ensure that the data encoding is preserved, and the size of the data, the interactions, the IO operations, all of those things are also taken care of. So whenever there is any threat, whenever there is any attack, these things also kind of alleviate some of these things, some of the risks that we have. So that way, I think data-wise, we are pretty confident. How big was the engineering team and how long it took to improve the solution? So when we got started, our engineering team was just four or five engineers, including Srishit. So I've been very fortunate to work with him on this particular project. So we started off with five engineers, and who kind of helped us build the scaffolding, who helped us build all of these processes, so that it's ready for the team to grow and include more engineers who can come and contribute to the customer facing features, to understand how these things are. They have a learning curve, so to understand how these things are done, and they can focus on the challenging functional problems that we have in such a complex requirement. So today, our team is about 15 people strong, and which includes the UI engineers and the backend engineers, and also two automation engineers. And we do not have a manual QA. It essentially has the domain-driven design, and the focus on the application has empowered the engineers to kind of think the customer impacts, the unit testing, the integration testings, and many other things. So to improve the solution, I think the solution is mostly an ongoing thing, because we have a huge roadmap ahead of us. As I said, that this is an enterprise application. But I think we are 15 people strong across these things, and we are continuously improving this. We're continuously learning something or the other, leveraging newer serverless services every single release, or probably every quarter we have something new. Every quarter we are improving the already existing solutions. Every quarter we are figuring out newer solutions to, say, the existing problem of timeouts, the existing problem of the data size limitations that we have. How do we leverage maybe sockets, or how do we ensure that things are real time and there is latency issues that may crop up for the clients, to alleviate some of those things and fasten those things and have a better experience. So it's a learning curve. We are not like completely there yet, but I think we've hit some sort of a harmony in the team, and the way we have embraced serverless, which has made it easier for us to look for more solutions. We're talking about moving to serverless here, but what if for some reason, let's say 1% changes, serverless service provider is down globally? Any backup plan to move back to the organization server? So the way I look at it is like, in that 1% chance, right? In the event there is something like that, I think then we will be in a global catastrophe for whatever reasons, and I'm not really sure if my customers would actually then be thinking about running their business or logging into this application. But that apart, yes, we have to still think about some of these things. At this point in time, we do not have a backup plan. But then some of these stacks and other things that we are using, we're hoping that we can easily migrate some of these things to another cloud provider, because that's also the leverage that we have. We have a code base, everything is protected, and we also have a stack, YAML. So we know what is actually our stack, and we just need to figure out some of those things. But if it's actually gone down that way, it might take a while, but that's more of a contingency plan rather than moving to, say, an organization server or on-premise.
Yeah, adding to that point, I mean, there's no possibility that only a serverless service can go down. It means that there are some servers also behind the scenes going down, which means that it's not just serverless, but a lot of other services that's going to get affected. But I think when we are building an application, we certainly have to build for resilience and have to take care of this. But yeah, it's a one-off chance, like you mentioned. Yeah.
Okay.
There are a few more questions. Let me bring them up.
How many microservices exist in the solution? So we have about 15 microservices. As I mentioned in the first few slides, our application basically has multiple business functions. It has customer relationship management. It has work order management, where it allows our customers to kind of manage their jobs, list of jobs, the bookkeeping of those things. It allows our customers to schedule jobs, dispatch job to their workforce, and they have workforce management in terms of their out of office, their hours of operation, their leave management, and many other solutions. And we also do have a lot of reporting aspects, and you have inventory management. So even each of these business functions that I'm naming, all of these things are like microservices. And within a business function, there could be more than one service, given how we have designed the user operation, like the user workflows, right? If you're looking at invoicing or making a payment, so that's a certain service which enables and empowers you to initiate a payment processing. It interacts with, say, another gateway, brings all of those information for you, as opposed to you want to do a bookkeeping of an invoice. Allow them to have some automation from when the job is completed, go ahead and create an invoice for the job. So these are separate services. So sometimes in our case, a single user operation under a business function can have multiple microservices. But even otherwise, if it's a very simple solution, you can actually have you can think of it as one microservices for a business function that we have. Under that, you have many operations, but all of those things are put into one, so that you don't have multiple lambdas as microservices which have multiple cold starts, and then the customers experience one part of the application within the same module working fine, but other part of the application does not have has a cold start. So we have kind of took some of these decisions to come up with the optimal number of microservices. So today I think we are at 15 microservices. And we have many other lambdas which does a lot of functions or event bridge and notifications and SES and many other things. But from a microservices perspective, that's our count.
We have one more from Sul. Yes.
What is the volume of transactions time, and how much latency are you able to achieve? So from a volume of transactions, and if I'm talking about, say, the customer transactions or customer operations, we are still not very high on the load. You could be talking about, say, and most of our customers are in the US. So it's an hour night time for in a given day. This is an enterprise app, so in a given day, if they're operating for 8 hours, so we see a peak during that time, and I think you could treat this as 10 QPS, 10 queries per second. We are at a very less load right now because, as I mentioned, we have 50 accounts, like 50 businesses who are on us, including small and medium businesses, and we do not have any enterprise customer yet, but they are small businesses which are probably operating with 10 users or 20 users. and the load that they generate typically translates to on an average of 10 to 15 QPS on the given day. But from an invocation standpoint, like across all these 15 microservices and many other lambdas that we have, if I'm just looking at the lambda invocations, we are at least like 20, 30,000 invocations on a given service. So you could think of it as 20, 30,000 invocations into 15 microservices, because each of these operations um, are packaged in some of those things. So we do not have a measure yet of what are average transactions that we are doing. And but then I would say that you can have it as an average of 10 to 15 QPS, like from a measure standpoint. And when it comes to latency, I think we have lambdas or microservices all the way from 30 milliseconds to say some of them being 500 and 600 milliseconds as well, depending on what they are doing behind the scenes. But on an average, whichever is REST APIs, which is customer facing, we are able to manage that on like between 150 to 300 milliseconds. So I think it's fairly good, because we also do a lot of client-side processing, which also fasten the user experience, lazy loading, component loading. So it doesn't really feel like there is a lot of weight when they're loading the data on the screens. But this is an average latency that we are able to achieve.
Awesome. I think, Sundar, there are still a couple of questions. Which are probably, if you can stay around and answer the questions, I think that would be great. We are already a little overshot. Thank you, Sundara, so much for doing this today and giving our audience a bit of an understanding of what it is to build an enterprise serverless application, and what are the various challenges and the trade-offs, if there are any, that we have taken. Thank you so much for being here today and sharing all of your knowledge. Thank you so much. I'm looking forward to having you in the future.
Absolutely, absolutely. It's my pleasure talking to all of you guys today. And on a Saturday, I see a lot of people and serverless enthusiasts. It's really encouraging. I have learned a lot myself with some of these sessions in the past, and how to small nuggets, which kind of opens up your brain to a few ideas. So I'd be very happy if I've contributed to that in any way today. Thank you so much.
Awesome. Thank you. Uh, so, so we will have Sundara around for a few more questions. So I think there are already a couple of them. So probably she'll be answering them. And in the meantime, over to you, Smile.
So let me quickly share a screen. Yeah. Is my screen visible, right, Srishit?
Yes, yes. Can you go to the presentation?
Yeah.
And go to the reinvent side. So for folks who have joined in a little later, I just want to reiterate a couple of announcements we did. One is about the AWS reInvent. So the registrations for reInvent has opened, and we will be sharing. I think Karthik has already posted the link in the chat section. For people who don't know about reInvent, it's AWS's flagship event that happens every year. And this year it's going to be a hybrid mode. That means it's going to be in person as well as virtual. So all of us can attend it at our homes. So please to go and register. There will be some really exciting sessions and interesting customer stories that is shared every single year. So please do go ahead and register for the same. And we have another announcement, which is the All Builders Welcome Grant. So as a part of reInvent, AWS sponsors the full paid expense trip to reInvent, where if you are an underrepresented technologist in the first 5 years of your career, that means you're starting your career and you've been doing a lot of things, but underrepresented or not very well acknowledged or anything like that, you can just go ahead and apply for the link that is shared here in the chat section, and probably you can apply for the grant and get a chance to go and watch reInvent in person in US last week. Yes. Yeah, I think these are the yeah, and one more good news sort of thing, not an announcement that we have crossed 500 members uh, uh, since the start, and it's been an amazing ride. And we are planning to come up with a lot more interesting sessions and a lot more hands-on stuff being planned for you guys. So please do keep supporting us. And a couple of more things that we wanted to share. Smile the GitHub, okay, please.
Yeah. So last but not the least, if you are looking for all the curated resources for all the sessions which we have, like all the 5 sessions, you can find it up in our GitHub repo, and you can star this repo so that you can get notifications. And if anytime we add anything new, you will get notified in your feed. Then, last but not the least, if you are looking for any specific sessions or you are planning to contribute for Serverless Saturday as a speaker, please reach out to us via these emails and we'll get back to you and we'll schedule a session with you. And you can last but not the least, if the session was helpful for you, please do provide us a feedback and we'll happy to read the feedback and improve upon it.
Yes. And reiterating what just Smile said, it's not just feedback. If you have some suggestions, if you want to listen to some specific services or topics from specific experts, then please do reach out to us, or you can just put it in the link that is shared, and we'll try and ensure that we can get that speaker for that particular topic in one of the Serverless Saturdays, and hope to have you soon on the next Serverless Saturdays edition. So thank you so much, everybody who have joined us today on a Saturday afternoon. And please do stay safe and stay home during these tough times. Thank you so much.